history doesn't just leave clues, it leaves inconsistencies, and that's where things start to fall apart, because the deeper you look, the more you notice something strange. The past doesn't behave the way it's supposed to. It doesn't progress cleanly. It doesn't evolve predictably. Instead, it jumps. It skips. It leaves behind moments of precision and understanding that seem to appear out of nowhere. And those moments don't fade. They remain, quietly challenging everything that came after them. This isn't just a mystery of what was built, it's a mystery of interruption, because something happened between what we see and what we're told, and whatever that is, we're still trying to catch up to it. Hidden beneath the limestone ridges of northwestern Bulgaria, near the Serbian border, Magura Cave presents one of the most perplexing archaeological enigmas in Europe. An underground archive where art, chemistry, and early symbolic thought converge in ways that challenge modern assumptions about prehistoric capability. Discovered in the late 19th century but only systematically studied during the 20th century, the cave stretches for more than 2,500 meters, with vast chambers that reach heights of over 20 meters, creating a stable microclimate that has remained remarkably consistent for millennia, averaging around 12 degrees Celsius with relatively stable humidity. Within these chambers, archaeologists have documented over 700 distinct figures, thus dated broadly between 8,000 and 4,000 years before present, spanning the late Neolithic to the early Bronze Age. At first glance, these figures resemble typical cave art, stylized humans, animals, geometric forms. But closer analysis reveals something far more complex. Sequences of repeated symbols, organized spatially in patterns that suggest intentional structuring rather than spontaneous expression. However, while the symbolic system itself remains undeciphered, it is the material used to create these images that has sparked one of the most controversial and unresolved debates in archaeological science: the use of bat guano as a primary pigment. Unlike the charcoal-based drawings found in sites such as Hoyo Cave, dated to approximately 36,000 years ago, or the mineral pigments used in Altamira Cave and Lascaux Cave, the images in Magura Cave are composed largely of bat guano, an organic material consisting of decomposed insect remains, uric acid, and microbial byproducts. From a modern materials science perspective, this choice appears counterintuitive, even irrational. Organic compounds are inherently unstable. They degrade over time, particularly in humid environments where microbial activity accelerates decomposition. Yet the figures in Magura Cave have persisted for thousands of years, maintaining their structural integrity and visual clarity in conditions that should, by all known chemical models, have led to rapid deterioration. This contradiction forms the core of the mystery. How did a seemingly fragile substance achieve such extraordinary longevity? Chemical analyses conducted during Bulgarian archaeological campaigns in the 20th century, particularly those intensifying in the 1970s and 1980s, confirmed the presence of organic residues consistent with guano, but also detected traces of mineral components, calcium compounds likely derived from the limestone environment, as well as possible silicate inclusions. This has led to the hypothesis that prehistoric inhabitants may have unintentionally or deliberately created a composite material, combining guano with mineral particles to produce a more stable pigment. In modern terms, this resembles the principle behind composite materials, where a weak base substance gains strength and durability through reinforcement. However, no direct evidence of intentional mixing processes has been conclusively identified, leaving open the question of whether this was a sluchany resultat of environmental interaction or a controlled technological practice. Comparative studies further deepen the puzzle. In Chauvet Cave, charcoal drawings, despite being created with a more stable carbon-based medium, show signs of fading and require strict environmental controls to preserve them today. In Lascaux Cave, the introduction of artificial lighting and human presence in the 20th century led to microbial growth that threatened the integrity of the paintings, forcing authorities to close the cave to the public. By contrast, Magura's guano-based images, created from a material far more susceptible to biological degradation, have endured with relatively less intervention. This paradox suggests that either the microclimatic conditions of Magura Cave are uniquely suited to preservation in ways not fully understood, or that the pigment itself possesses properties that modern science has yet to replicate. One emerging line of inquiry focuses on the chemical transformation of guano over time. As guano decomposes, it can undergo mineralization, gradually incorporating elements from its surrounding environment and forming more stable compounds. In the presence of calcium-rich limestone and under conditions of limited airflow, it is theoretically possible for guano to harden or chemically bond with the rock surface, effectively becoming part of the cave wall itself. If this process occurred in Magura, it would explain the durability of the images, but it raises another question. Did prehistoric humans understand, even intuitively, that applying guano in this environment would result in long-term preservation? The deliberate placement of drawings in specific zones of the cave, areas with optimal airflow, minimal water runoff, and stable temperature, suggests a level of environmental awareness that borders on proto-scientific reasoning. Archaeological excavations conducted across multiple phases, including systematic surveys in the mid-20th century and more refined stratigraphic analyses in the early 21st century, have revealed that the cave was not used continuously, but rather revisited across different cultural periods. Layers of human activity, including pottery fragments, tools, and evidence of ritual use, indicate that the site may have held symbolic or ceremonial significance. This raises the possibility that knowledge of the pigment's properties was transmitted across generations, preserved not in written form but through practice and tradition. If so, the guano-based pigment was not merely a convenient material, but part of a technological system embedded within a broader cultural framework. The implications extend beyond Magura itself. If prehistoric communities possessed even a rudimentary understanding of how to manipulate organic and inorganic materials to achieve long-term stability, then the conventional timeline of material science may need to be reconsidered. The gap between what is assumed to be primitive and what is demonstrably achieved becomes increasingly difficult to reconcile. Moreover, attempts to recreate the Magura pigment under laboratory conditions have yet to produce identical results, suggesting that subtle variables, perhaps microbial ecosystems unique to the cave or precise environmental conditions, play a critical role that has not been fully captured. Beyond the chemistry, the spatial organization of the drawings adds another layer of complexity. Certain sequences appear to align with cyclical patterns, leading some researchers to propose that the images functioned as a form of calendrical system, possibly tracking lunar phases or seasonal changes. If true, the durability of the pigment would have been essential, ensuring that the information remained accessible over long periods. In this context, the choice of material becomes even more significant. It transforms the drawings from mere artistic expression into a form of data storage, where longevity is a functional requirement rather than a byproduct. Despite decades of research, no single theory fully explains the mystery. The guano pigment remains a rare anomaly in prehistoric art, challenging what we think early humans were capable of, whether it was intentional innovation, learned experience, or a unique natural process. The paintings in Magura Cave blur the line between primitive methods and advanced knowledge. Even today, they endure as more than ancient art. They suggest a level of technological intuition we may still not fully understand. Was the ink made from bat guano in Magura Cave the result of intentional technology, or just a strange natural coincidence that ancient humans accidentally discovered? Share your thoughts in the comments below. Hidden within the limestone formations of the Swabian Jura in southern Germany, Hoyo Fels Cave has emerged as one of the most extraordinary archaeological sites ever discovered, not simply for its age, stretching back over 40,000 years, but for the unsettling sophistication of the objects found within it. Excavations led by archaeologist Nicholas Conrad from the University of Tübingen, particularly between the early 2000s and the 2010s, have revealed a dense concentration of artifacts attributed to the Aurignacian culture, often associated with some of the earliest modern humans in Europe. Among these discoveries are musical instruments, figurative sculptures, and personal ornaments, each pushing the boundaries of what researchers once believed possible for Ice Age societies. However, and beyond the artistic and symbolic significance of these objects lies a deeper and more perplexing mystery, one centered on material science and engineering, the seemingly irrational yet highly effective technology used to process mammoth ivory. Mammoth ivory is not a forgiving material. Structurally, it is composed of dense dentin, with a complex internal pattern known as Schrieger lines, making it both extremely hard and highly susceptible to cracking under stress. Modern artisans working with ivory, even with precision tools, often face challenges in preventing fractures during cutting or carving. Yet, at Hoyo Fels, artifacts dating back approximately 35,000 to 40,000 years display a level of craftsmanship that suggests not only familiarity with the material, but a mastery of it. And one of the most striking examples is the ivory flute discovered in 2009, reconstructed from multiple fragments and estimated to be around 35,000 years old. Unlike simpler bone flutes found in other regions, this instrument was not merely hollowed out. Instead, it was carefully split longitudinally, each half carved with remarkable precision, then reassembled to form a sealed acoustic chamber. The seams aligned so tightly that even under microscopic analysis, the join appears deliberate and controlled, raising immediate questions about the techniques used to achieve such precision without metal tools or adhesives as we understand them today. To put this into perspective, Kia experimental archaeology has attempted to replicate similar processes using only stone tools comparable to those available during the Aurignacian period. Results consistently show that while it is possible to carve ivory using flint blades, the process is slow, unpredictable, and prone to catastrophic cracking, especially when attempting to hollow out internal cavities or create thin walls. In contrast, the Hoyo Fels artifacts exhibit smooth internal surfaces and consistent wall thickness, indicating a level of control that exceeds what would be expected from purely trial and error methods. Some researchers have proposed that prehistoric craftsmen may have used controlled heating or soaking techniques to alter the mechanical properties of the ivory, softening it temporarily to reduce brittleness. However, there is currently no definitive archaeological evidence of such processes at the site. No specialized heating installations, no residue of binding agents, and no clear sequence of production stages have been identified, leaving a critical gap between the observed results and the presumed methods. This gap becomes even more pronounced when comparing Hoyo Fels to other contemporary sites. In locations such as Geissenklusteler Cave and Vogelherd Cave, similar ivory artifacts have been found, including figurines and musical instruments, yet the density and apparent refinement of the Hoyo Fels assemblage stand out. The famous Venus of Hoyo Fels, dated to roughly 40,000 years ago, is carved from a single piece of mammoth ivory and features exaggerated anatomical forms with deeply incised contours. Achieving such depth and curvature without fracturing the material would require not only technical skill, but also an intimate understanding of stress distribution within the ivory, knowledge that, in modern contexts, is often informed by material science and engineering principles. The figurine surface also shows signs of smoothing and finishing, possibly through abrasion with fine-grained materials, suggesting a multi-stage production process that goes far beyond simple carving. Radiocarbon dating of the surrounding sediment layers places these artifacts firmly within a narrow time frame, indicating that this technological capability did not evolve gradually over tens of thousands of years at this site, but appeared relatively abruptly. This aligns with what some scholars describe as the Upper Paleolithic Revolution, or Creative Explosion, a period marked by a sudden proliferation of symbolic and technological innovations. Yet even within this broader context, the specific techniques observed at Hohlefels remain anomalous. For example, while bone tools and simple carvings are widespread across Europe during this period, the complex manipulation of ivory, particularly the creation of composite structures like the flute, remains rare and geographically concentrated. Another layer of mystery lies in the apparent absence of corresponding tools. Excavations at Hohlefels have yielded numerous stone implements, including blades and burins, but none that definitively account for the fine drilling and internal shaping required for the ivory artifacts. And microscopic wear analysis has identified some tools that may have been used for carving, yet the precision of the finished object suggests either the existence of specialized tools that have not been preserved or techniques that leave minimal trace. Organic tools made from wood or plant fibers could have played a role, but their complete disappearance over tens of thousands of years makes this hypothesis difficult to verify. Alternatively, it is possible that the artisans employed methods that maximized efficiency and minimized tool wear, achieving results that seem disproportionate to the apparent simplicity of their toolkit. Excavation campaigns throughout the 2000s and 2010s have continued to refine our understanding of the site, and with stratigraphic analysis confirming repeated human occupation and consistent production of high-quality artifacts. Despite these advances, the fundamental question remains unresolved. How did these early humans develop and transmit such specialized knowledge? The consistency observed across multiple artifacts suggests that this was not the work of isolated individuals, but part of a shared technological tradition, possibly passed down through generations. This implies the existence of teaching methods, apprenticeship systems, and perhaps even conceptual frameworks for understanding materials, elements typically associated with much later, more complex societies. When compared to later civilizations, such as those of ancient Egypt or Mesopotamia, where advanced material processing is well documented and supported by written records, the achievements at Hohlefels appear even more enigmatic. Those later cultures had access to metallurgy, organized labor, and accumulated knowledge over millennia. In contrast, the inhabitants of Hohlefels operated within a hunter-gatherer context, without agriculture, without permanent settlements, and without any known system of writing. Yet in at least one domain, the manipulation of a notoriously difficult material, they achieved results that challenge modern assumptions about the limitations of prehistoric technology. What do you think allowed humans over 40,000 years ago to process mammoth ivory with seemingly impossible precision? Was it a lost skill, or a form of knowledge we still don't fully understand? Where are you watching this video from, and what time of day is it for you? Share your location and time in the comments below. Beneath the sunlit cliffs of southern Spain, where the Mediterranean appears calm and predictable, a vast underground world tells a far more unsettling story, one that challenges our understanding of prehistoric intelligence and technological capability. Hidden near the modern town of Nerja The Nerja Cave stretches for nearly 5 kilometers, a colossal labyrinth of chambers, tunnels, and vertical shafts that plunge deep into total darkness. Discovered only in 1959 by a group of local youths exploring a narrow crevice, the cave quickly revealed itself not merely as a geological marvel, but as a site layered with human activity that may date back over 40,000 years. Yet from its towering stalactite columns, one of which rises approximately 32 meters high and spans nearly 13 meters in diameter, to its vast cathedral-like chambers, with acoustics so refined they are still used for concerts today, everything about Nerja Cave feels improbably structured. Yet the true mystery does not lie in its scale, but in the subtle traces left behind by ancient hands. Traces that raise a question modern science has yet to fully answer. How did prehistoric humans operate in an environment where light does not exist? Deep within the cave, far beyond the reach of natural daylight, researchers have identified markings, pigments, and possible cave paintings whose origins remain contested. Early analyses suggested that some of these markings could date back more than 42,000 years, placing them within the time frame of Neanderthals rather than modern Homo sapiens. If accurate, this would radically reshape our assumptions about Neanderthal cognition, implying not only symbolic thought, but also a level of environmental adaptation far more advanced than previously accepted. However, even setting aside the debate over authorship, a more immediate and perplexing problem emerges. How were these images created at all? The sections of Nerja Cave where such markings appear are located hundreds of meters from the nearest entrance, in zones where absolute darkness dominates, a darkness so complete that even today, with artificial lighting, navigation remains difficult and disorienting. To understand the scale of this challenge, it is useful to compare Nerja with other prehistoric cave sites such as Lascaux Cave in France or Altamira Cave in northern Spain. In those caves, evidence of torch use is abundant: soot deposits on ceilings, charcoal residues, and clear burn marks that indicate repeated lighting of fires. In Lascaux, for instance, archaeologists have documented extensive blackening of surfaces consistent with sustained torch use, alongside portable stone lamps fueled by animal fat. These lamps, when reconstructed experimentally, produce a modest but steady flame capable of illuminating a small area for up to 1 hour per filling. Yet even in Lascaux, most paintings are located within a manageable distance from entrances or within chambers where ventilation allows smoke to dissipate. Nerja, by contrast, presents a far harsher environment, yet many of its deepest chambers show little to no evidence of heavy soot accumulation, despite the apparent presence of human activity. This absence is not merely a minor detail, it is a contradiction. If prehistoric artists relied on torches similar to those used in Lascaux, we would expect to find consistent layers of carbon residue on the cave ceilings, especially in confined spaces where smoke would accumulate rapidly. The physics of combustion makes this unavoidable. Burning wood produces particulate matter that adheres to nearby surfaces, particularly in enclosed environments with limited airflow. Yet in several key areas of Nerja Cave, such evidence is either minimal or entirely absent. This has led some researchers to propose the use of more refined lighting technologies, such as stone lamps burning animal fat, a method known to produce less smoke than open torches. Experimental archaeology supports this possibility to an extent. Replicas of Paleolithic fat lamps, using materials like limestone bowls and wick fibers made from moss or plant fibers, can generate a steady, low-smoke flame for extended periods. However, even these lamps are not entirely clean. Over prolonged use, they still leave detectable residues, especially in enclosed environments. This discrepancy raises a deeper and more troubling question. Were the inhabitants of Nerja Cave employing lighting techniques that we do not yet fully understand? Some hypotheses suggest that they may have carefully selected specific types of fuel, perhaps animal fats with lower impurity content or plant oils that burn more cleanly. Others propose that they strategically used airflow within the cave system, positioning themselves in zones where natural ventilation channels would carry smoke away. Indeed, modern surveys of Nerja have identified subtle airflow currents in certain sections, created by differences in temperature and pressure between entrances. But here again, the problem becomes one of precision. To exploit such airflow effectively, prehistoric humans would have needed an intimate and detailed understanding of the cave's internal dynamics, knowledge that would likely require repeated exploration, mapping, and perhaps even a form of spatial memory far more advanced than traditionally attributed to Paleolithic societies. There is also the issue of duration. Creating even a single cave painting is not an instantaneous act. It requires preparation, mixing of pigments, and careful application. In sites like Altamira, detailed studies have shown that some paintings were created over extended periods, involving multiple layers and revisions. If similar processes occurred in Nerja, then the artist would have needed sustained illumination, not just brief flashes of light. This implies a logistical system, a supply of fuel, tools for maintaining flames, and perhaps even designated individuals responsible for managing light sources. Yet despite extensive excavations conducted since the 1960s, including systematic studies by Spanish archaeological teams and later interdisciplinary research involving geologists, chemists, and anthropologists, clear evidence of such a system remains elusive. Adding to the mystery is the spatial distribution of human traces within the cave. Rather than clustering near entrances or easily accessible areas, some of the most intriguing markings appear in locations that require complex navigation to reach. These are not random wanderings. They suggest intentional movement deep into the cave's interior. Modern explorers equipped with headlamps and GPS mapping still find certain sections of Nerja disorienting, with similar-looking passages and sudden drops that can easily lead to disorientation. For prehistoric individuals to traverse these areas repeatedly, and to do so while carrying fragile light sources, implies a level of environmental mastery that challenges conventional narratives of early human limitation. One of the most compelling comparisons can be drawn with the Chauvet Cave in France, where paintings dated to around 36,000 years ago also appear in deep, dark chambers. There, however, archaeologists have documented clear evidence of torch use, including charcoal fragments and soot patterns that map the movement of artists through the cave. In Nerja, the relative absence of such clear traces forces us to consider alternative explanations. Could the lighting have been intermittent, used only in short bursts? Could there have been techniques for shielding flames or filtering smoke? Or, more provocatively, are we simply failing to detect the evidence because it does not conform to the models we expect? The question of light in Nerja Cave is not merely a technical curiosity. It strikes at the heart of how we understand prehistoric innovation. Technology is often defined not by complexity, but by effectiveness within a given context. In an environment of total darkness, the ability to produce stable, low-smoke illumination is not a trivial skill. It is a critical adaptation. And yet, the archaeological record at Nerja offers only fragments of this story, hints without a complete blueprint. Each new excavation season adds data but rarely definitive answers. Recent studies employing advanced techniques such as microstratigraphic analysis and residue chemistry have attempted to identify trace compounds associated with combustion, but results remain inconclusive, often complicated by natural processes such as mineral deposition and microbial activity that can obscure or alter original evidence over tens of thousands of years. If prehistoric humans truly mastered a lighting technology that left almost no trace in complete darkness like in Magura Cave, do you think it was a lost technique, or are we simply not advanced enough yet to recognize it? Share your thoughts in the comments below. Deep beneath the dense, almost impenetrable canopy of the Amazon rainforest in southeastern Ecuador lies Cueva de los Taios, a vast subterranean network that has, for decades, resisted simple classification as either a natural geological formation or something far more deliberate. What makes this cave system particularly unsettling to both explorers and scientists is not merely its depth, vertical shafts dropping more than 200 meters into darkness, nor its sheer scale, but rather the recurring reports of structural features that appear almost too perfect to be the product of natural processes alone. In the language of geology, caves formed through water erosion, tectonic activity, and mineral dissolution tend to exhibit irregular morphologies, winding tunnels, jagged surfaces, asymmetrical chambers, an unpredictable spatial organization. Yet in certain sections of Taios, explorers have described something strikingly different. Flat plains that extend for meters with minimal deviation, sharply defined edges approaching right angles, and corridors that maintain a surprisingly constant width and direction, as though guided by intention rather than chance. These observations, first widely circulated in the mid-20th century and later amplified by figures such as Erich von Däniken, ignited a debate that continues to this day. Are these perfect structures the result of rare but natural geological conditions, or do they hint at an unknown form of ancient engineering? To evaluate this question, it is essential to examine both the claims and the counter-arguments with equal rigor. On one hand, geology provides mechanisms that can, under specific circumstances, produce planar surfaces and linear voids. Fault lines, for instance, can fracture rock along relatively straight planes, and when water exploits these weaknesses over thousands or even millions of years, it can enlarge them into passageways that appear unusually straight. In limestone cave systems, dissolution along joints can create corridors with parallel walls, sometimes giving the illusion of artificial carving. However, the anomaly in Taios lies not merely in the presence of such features, but in their reported consistency and apparent organization. Multiple accounts describe sections where walls are not only flat but also smooth, where angles are not just approximate but sharply defined, and where passages extend in linear trajectories that seem to defy the randomness typically associated with natural cave formation. To better contextualize this, comparisons with known human-made structures are unavoidable. In sites such as Ellora caves, entire temples were carved directly into basalt rock with remarkable precision, producing straight corridors, symmetrical chambers, and finely finished surfaces. Similarly, the ancient city of Petra demonstrates how human craftsmanship can transform solid rock into architectural forms with clean lines and deliberate geometry. Yet these examples, while impressive, differ fundamentally from Taios in terms of environment and feasibility. Both Ellora and Petra were constructed in accessible locations with abundant light, space for large workforces, and the logistical capacity to remove debris and transport materials. In contrast, any hypothetical engineering effort within Taios would have required operating in complete darkness, navigating vertical drops exceeding 200 meters, and working in confined, hazardous conditions, where even modern expeditions rely on advanced climbing equipment, artificial lighting, and precise coordination. The absence of tool marks, construction debris, or any definitive archaeological evidence further complicates the hypothesis of artificial origin, as such traces are typically abundant in confirmed human-made sites. The most comprehensive scientific investigation of the cave occurred in 1976, when a large-scale expedition involving over 100 participants, including scientists, military personnel, and the Apollo astronaut Neil Armstrong, undertook a systematic exploration of the system. The goals were clear: to map the cave, document its features, and evaluate the extraordinary claims that had captured global attention. The findings, however, were both conclusive and inconclusive in equal measure. On the one hand, the expedition did not uncover any evidence of artificial structures, metallic artifacts, or the so-called library described in earlier accounts. Geological explanations were deemed sufficient to account for the observed formations, and the cave was largely classified as a natural system shaped by tectonic and erosional processes. On the other hand, the expedition also acknowledged the immense complexity of the cave and the fact that significant portions remained unexplored. In other words, while no evidence of artificial construction was found, the investigation did not, and perhaps could not, fully eliminate the possibility, given the scale and inaccessibility of the environment. What continues to sustain the mystery is the persistence of specific anomalies that resist easy explanation. Reports from different decades, often independent of one another, consistently mention similar features. Unusually straight passages, flat and seemingly polished walls, and spatial arrangements that appear organized rather than random. While it is possible that cognitive bias, or the human tendency to perceive patterns, plays a role, the repetition of these descriptions across multiple sources cannot be entirely dismissed. Furthermore, the cultural context adds another layer of intrigue. The indigenous Shuar people, who have long inhabited the region, regard the cave as sacred and have traditionally restricted access to its depths. Their oral traditions speak of hidden knowledge and powerful objects within the cave, narratives that, while not scientifically verifiable, align intriguingly with the broader pattern of unexplained claims associated with Taios. Historically, such traditions have sometimes preserved fragments of truth that only later find partial confirmation through archaeological discovery, suggesting that they deserve consideration rather than outright dismissal. From a technological standpoint, the implications of any confirmed artificial modification within Taios would be extraordinary. Creating large, at flat surfaces and precise angles in hard rock requires not only tools capable of exerting controlled force, but also an understanding of geometry, material properties, and structural integrity. Achieving this in a subterranean environment would further necessitate solutions for illumination, ventilation, and navigation, challenges that remain significant even with modern technology. For comparison, in the construction of the Ellora caves, artisans used iron tools and worked in daylight conditions, leaving behind clear evidence of their methods. In Petra, the carving process produced visible tool marks and debris, providing a tangible record of human activity. In Taios, by contrast, such evidence is conspicuously absent, which either strengthens the case for natural formation or raises the far more controversial possibility of techniques that do not leave easily recognizable traces. Ultimately, the question of whether the two perfect structures inside Cueva de los Taios are natural or artificial remains unanswered, not due to a lack of research, but because of the limits of current knowledge and exploration. With much of the cave still uncharted and many features continuing to challenge scientific understanding, Taios remains one of the most compelling mysteries, where the line between nature and intention is still blurred. What do you think? Are the two perfect structures inside Taios Cave the result of natural forces or the remnants of a lost ancient technology? Share your thoughts in the comments below. Hidden deep within the dense jungles of Belize, the cave known as Aktun Tunichil Muknal, often abbreviated as ATM, has become one of the most haunting archaeological sites ever discovered, not only because of its preserved human remains and ritual artifacts, but because of the profound technological questions it raises about how the ancient Maya interacted with one of the most extreme environments imaginable. First systematically explored in 1989 by archaeologist Jaime Ao, the cave revealed an astonishing concentration of ceremonial deposits, over 1,400 catalogued artifacts, including ceramics, stone tools, and at least 14 human skeletons, many of them located hundreds of meters from the entrance. Beyond zones of natural light and deep within chambers accessible only by swimming through cold subterranean rivers, climbing slick limestone formations and navigating total darkness. Yet among all the mysteries contained within ATM, one stands out as both subtle and deeply perplexing. The question of light. How did the Maya illuminate this pitch-black environment so effectively, so consistently, and with so little physical evidence that modern science can barely reconstruct the process? In a cave where even today trained guides require headlamps with outputs exceeding 200 to 300 lumens to move safely, the Maya ventured far deeper with nothing more than organic materials. Archaeological evidence suggests the use of resin-based torches, likely derived from copal, a tree resin widely used in Mesoamerican rituals, but the implications of this are far more complex than they first appear. Experimental archaeology has demonstrated that a typical resin torch burns for approximately 20 to 30 minutes, producing light in the range of 10 to 50 lumens, depending on composition and airflow conditions. In an open environment, this would already be dim. Inside a cave with high humidity, often exceeding 95%, and limited oxygen circulation, maintaining a stable flame becomes exponentially more difficult. Moisture interferes with combustion, oxygen depletion weakens flame intensity, and the absence of airflow prevents smoke from dissipating. Yet, paradoxically, the interior chambers of ATM Cave show surprisingly low levels of soot accumulation on ceilings and walls. This observation has been confirmed through multiple surveys conducted in the 1990s and early 2000s, where carbon residue was found to be present but far less dense than expected if dozens of torches had been used repeatedly over centuries. To understand the scale of this anomaly, it is useful to compare ATM with other cave systems used by ancient cultures. In the famous Paleolithic caves of Lascaux Cave in France, dating back over 17,000 years, extensive soot deposits clearly mark areas where animal fat lamps and torches were used, leaving blackened ceilings that persist to this day. Similarly, in Altamira Cave in Spain, evidence of prolonged illumination is unmistakable, now with thick layers of carbon residue correlating with areas of artistic activity. Even in Mesoamerica, caves such as Naj Tunic in Guatemala display more obvious traces of torch use, including charcoal fragments and burn marks. By contrast, ATM Cave presents a contradiction: clear evidence of repeated human presence deep within, but a relative absence of the environmental scars typically associated with sustained fire use. This raises a critical question: were the Maya using a different kind of lighting technology, one optimized for low smoke output and high efficiency? One hypothesis suggests that the Maya may have refined their torch composition beyond simple resin, potentially combining copal with other plant materials to create a cleaner burning fuel. Ethnographic studies of traditional torch making in Central America indicate that certain hardwood resins, when mixed with fibrous plant matter and wrapped in specific ways, can produce a more stable flame with reduced smoke. However, even under ideal conditions, completely eliminating soot is virtually impossible, especially in enclosed spaces. Another possibility is that the Maya used multiple smaller light sources, rather than a few large torches, distributing illumination in a way that minimized localized smoke buildup. This would require a coordinated system of movement and placement, suggesting not only technical knowledge, but also an organized ritual protocol governing how light was managed within the cave. More speculative, but increasingly discussed, is the idea that the Maya understood and exploited the cave's microenvironment in ways modern researchers are only beginning to appreciate. Subtle air currents, temperature gradients, and variations in chamber geometry could influence how smoke behaves, potentially allowing it to disperse more effectively than expected. Some chambers within ATM show evidence of airflow patterns that are not immediately obvious, possibly created by differences in elevation or hidden passages. If the Maya were aware of these dynamics, they may have deliberately chosen routes and ritual spaces that optimize both visibility and air quality. Such knowledge would not require advanced instruments, but it would demand generations of accumulated observational experience, a form of environmental engineering rooted in intimate familiarity with the cave itself. Even more intriguing is the possibility that light within ATM was not purely functional, but symbolic, and therefore used sparingly and strategically rather than continuously. In many Maya cosmological beliefs, caves were seen as entrances to the underworld, known as Xibalba, a realm associated with darkness, death, and transformation. Within this framework, darkness was not merely an obstacle to overcome, but an essential component of the ritual experience. Light, then, may have been introduced only at specific moments, in controlled bursts, to reveal sacred objects, guide ceremonial actions, or create dramatic visual effects. This would significantly reduce the total amount of soot produced over time, aligning with the archaeological evidence. It also suggests a level of intentionality in light usage that goes beyond basic survival, entering the realm of psychological and spiritual design. The distribution of artifacts within the cave further supports the idea of deliberate lighting strategies. Many of the most significant finds, including the famous Crystal Maiden, a calcified skeleton whose bones sparkle under modern light, are located in areas that would have required precise navigation and targeted illumination. The placement of ceramic vessels, often intentionally broken in situ, appears to follow patterns that are not random but structured, implying that participants could see well enough to perform specific actions in specific locations. This level of precision would be difficult to achieve with unreliable or inconsistent lighting, reinforcing the notion that the Maya had developed a dependable method of illumination, even if its exact nature remains elusive. Excavation records from the Belize Institute of Archaeology indicate that some torch fragments have indeed been recovered, but they are relatively scarce compared to the scale of human activity inferred from the site. This discrepancy suggests either that organic materials decomposed more completely than expected, or that the number of light sources used was lower than modern assumptions would predict. If the latter is true, it implies a remarkable efficiency, an ability to do more with less, to navigate and operate in darkness with minimal reliance on artificial light. Such efficiency could stem from a combination of factors: heightened sensory adaptation, memorized spatial layouts, and perhaps even ritualized movement patterns that reduce the need for constant visibility. In summary, the mystery of light inside Aktuntunishil Muknal is not just about torches or fuel, it reflects how we define technology itself. While modern thinking links technology to machines and visible traces, the Maya may have relied on knowledge of materials, environment, and human perception to create an invisible technology that left almost no physical evidence. The very absence of clear traces at ATM may actually be the clue, pointing to a more subtle and sophisticated form of innovation than we usually recognize. Do you think the Maya truly developed an invisible technology to master complete darkness inside Aktuntunishil Muknal? Or are we simply missing something obvious? Share your thoughts in the comments below. high above the windswept expanse of the Tibetan Plateau, where the air thins to nearly 60% of sea level oxygen and winter temperatures routinely plunge below -10 degrees Celsius. The shadowed entrance of Baishia Karst Cave conceals a mystery that challenges not only our understanding of human evolution, but also our assumptions about the technological limits of prehistoric life. Unlike the monumental ruins of stone cities or precisely carved megaliths, this cave offers something far more unsettling: evidence that an ancient human lineage, one we barely understand, may have mastered survival in one of the harshest environments on Earth through methods that remained frustratingly elusive. The discovery itself was unconventional. Long before modern archaeology reached the site, the cave had been a place of spiritual significance to Tibetan monks, who preserved within it a fossilized jawbone later identified as belonging to a Denisovan individual. When scientists finally analyzed the specimen using paleoproteomic techniques, extracting ancient proteins rather than degraded DNA, they confirmed that this high-altitude refuge was occupied by Denisovans as far back as 160,000 years ago, a timeline that predates the arrival of modern Homo sapiens in such extreme elevations by tens of thousands of years. This alone was astonishing. Today, populations living on the Tibetan Plateau possess genetic adaptations, most notably variants of the EPAS1 gene, that allow them to process oxygen efficiently in thin air. Genetic studies suggest that this adaptation may have been inherited from Denisovans, implying that these ancient humans had already solved a physiological challenge that would take modern humans millennia to overcome. But biology alone does not explain everything. The deeper mystery lies not just in how they survived, but in how consistently and sustainably they did so. Inside the cave, archaeological excavations conducted over multiple campaigns, particularly those led by Chinese researchers in the late 2010 and early 2020, have revealed layered sediments rich with charcoal fragments, burned bones, and stone artifacts. These findings confirm repeated long-term occupation rather than brief sporadic visits. Yet maintaining fire in such an environment should have been extraordinarily difficult. At high altitude, reduced oxygen levels impair combustion efficiency, while cold and humidity within karst caves further complicate ignition and heat retention. Experimental archaeology suggests that even modern humans struggle to sustain open flames under similar conditions without carefully selected fuels and controlled airflow, and yet the evidence at Baishia indicates that fire was not only present, but reliably maintained across generations. The charcoal concentrations are neither random nor sparse. They appear in distinct stratified layers, implying repeated and possibly continuous use of fire for extended periods. This raises a series of unresolved questions. What kind of fuel were the Denisovans using? Large timber would have been scarce in such alpine regions, and transporting it into the cave would require planning and coordination. Smaller organic materials burn quickly and inefficiently in low-oxygen environments, unless used with techniques that enhance combustion. Some researchers have speculated that they may have utilized animal fat, bone marrow, or even dung as supplementary fuel sources, materials known to produce longer-lasting heat when properly managed. But such strategies require not just opportunistic behavior, but an understanding, whether intuitive or learned, of combustion optimization. In modern terms, this begins to resemble a primitive form of energy engineering. Comparisons with other prehistoric sites deepen the mystery. At Denisova Cave, also associated with Denisovans, evidence of fire use exists, but the environmental conditions are far less extreme. Oxygen levels are higher, and temperatures, while cold, are not compounded by the physiological stress of high altitude. Similarly, at Blombos Cave, early Homo sapiens demonstrated remarkable cognitive and symbolic behavior, including pigment processing and tool production, yet they operated in a comparatively stable coastal climate. Nowhere else do we see such a combination of extreme altitude, sustained habitation, and persistent fire use as at Baishia. This suggests that the Denisovans here were not merely surviving, they were systematically adapting their environment to make survival viable. The spatial organization of the cave adds another layer of intrigue. Excavation data indicates that different zones within the cave were used for distinct purposes, with concentrations of ash, tools, and organic remains distributed in patterns that hint at intentional planning. And a fire was not lit randomly. It appears to have been placed in locations that maximize heat retention while minimizing smoke accumulation, an especially critical factor in a confined, oxygen-poor space. This implies a level of environmental awareness and perhaps even experimentation over time. In modern engineering, managing airflow and combustion within enclosed spaces is a complex challenge. Could Denisovans have developed rudimentary methods, perhaps through trial and error, to regulate these variables? There are no preserved tools or structures that explicitly demonstrate such techniques, but the indirect evidence is difficult to ignore. Even more puzzling is the apparent efficiency of their system. Despite the harsh conditions, there is no clear evidence of catastrophic occupation failures, no layers dominated by abrupt abandonment or mass die-off. Instead, the archaeological record suggests continuity. This continuity implies that whatever methods they employed were not only effective, but replicable across generations. In other words, this was not a one-time survival event, but a stable adaptation strategy. And yet, the physical traces of that strategy remain almost invisible. This is perhaps the most unsettling aspect of Baishia Cave. In many ancient sites, technological sophistication is expressed through durable artifacts, stone tools, constructed features, or modified landscapes. Here, the technology may have been largely intangible. Knowledge of fuel selection, fire management, spatial positioning, and physiological endurance passed down without leaving clear mechanical signatures. It is a form of technology that exists at the intersection of biology, behavior, and environment. A system rather than a set of tools. Modern researchers are only beginning to appreciate how complex such systems can be, especially when developed under extreme selective pressure. Adding to the enigma is the preservation of ancient proteins within the cave's fossil record. The successful identification of Denisovans through paleoproteomics was not merely a methodological breakthrough, it also suggests that the cave's microenvironment has unique properties that slow biological degradation. Whether this is due to temperature stability, mineral composition, or other factors is still under investigation, but it raises an intriguing possibility that Denisovans may have unconsciously, or perhaps even deliberately, favoured environments that enhance preservation, whether of food, materials, or biological remains. While there is no direct evidence of intentional biochemical manipulation, the interplay between environment and survival strategy at Baishia is too consistent to dismiss as coincidence. Ultimately, Baishia Cave forces us to reconsider what we mean by technology in a prehistoric context. If technology is defined not only by tools, but by the ability to manipulate and optimize one's environment to ensure survival, then the Denisovans of Baishia may have possessed a form of technological intelligence that leaves almost no trace in the traditional archaeological sense. They lived where survival should have been nearly impossible, maintained fire where combustion should have been unreliable, and did so not briefly, but over tens of thousands of years. The question is no longer whether they adapted, but how. And until we can answer that, the cold, silent chambers of Baishia will continue to hold one of the most profound and unsettling mysteries of the ancient world. The possibility that a forgotten branch of humanity once mastered a way of living that we are only now beginning to comprehend. Do you think the Denisovans simply adapted biologically? Or did they possess a form of survival technology that we still cannot recognize? Share your thoughts in the comments below. Something about Hoyo Negro does not behave like a simple archaeological site. It behaves like a contradiction preserved in darkness. Hidden deep within the vast submerged labyrinth of the Sacactan system in Mexico's Yucatan Peninsula, this massive vertical sinkhole, dropping more than 30 meters into a chamber of still, mineral-rich water, has become one of the most important and perplexing windows into the earliest human presence in the Americas. First brought to scientific attention in the early 21st century by underwater explorers mapping the cave network, the site gained global recognition after the discovery of a nearly complete human skeleton at its base, later named Naya. Radiocarbon dating and uranium-thorium analysis placed her at approximately 12 to 13,000 years old, making her one of the oldest and most complete human remains ever found in the New World. Yet while Naya's bones reshaped theories of human migration, revealing a striking mismatch between cranial morphology resembling Southeast Asian populations and DNA linking her directly to modern Native Americans, it is not the skeleton alone that unsettles researchers. It is the environment in which she was found, and more specifically, the technological implications hidden in the darkness that once surrounded her. To understand the magnitude of the mystery, one must reconstruct the landscape as it existed during the late Pleistocene. At that time, global sea levels were between 100 and 120 meters lower than today, meaning that the entire Sacactan system, including Hoyo Negro, was dry, forming an immense network of caves stretching for hundreds of kilometers beneath the jungle. But dry does not mean accessible. Even in its exposed state, the system would have been a maze of narrow passages, sudden vertical drops, unstable limestone surfaces, and absolute darkness beyond a few meters from any entrance. Modern divers equipped with high-intensity LED systems, redundant oxygen supplies, and detailed cave maps still require hours of preparation to reach Hoyo Negro safely. In contrast, a human entering this system over 12,000 years ago would have faced a total absence of natural light, no navigational aids, and terrain that punishes even minor miscalculations. And yet, Naya, or people like her, did enter. This is where the most difficult and least resolved question emerges. How did ancient humans illuminate and navigate such an environment? The assumption that they relied on simple torches immediately encounters a series of problems. In other cave systems around the world, such as Cosca Cave in France, clear archaeological evidence of torch use has been preserved. Charcoal residues, soot deposits on ceilings, and burnt fragments embedded in sediment layers. These traces allow researchers to reconstruct not only the presence of fire, but also its frequency and intensity. At Hoyo Negro, however, such evidence is conspicuously absent, despite extensive surveys conducted by teams from institutions including the Instituto Nacional de Antropología y Historia, INA, and international cave exploration groups throughout the 2000s and the 2010s, no definitive soot layers, no concentrated charcoal deposits, and no clear remains of burnt wood have been documented in the passages leading to the chamber. This absence is not trivial. It challenges the fundamental assumption that fire was the primary lighting technology used in deep cave exploration during the late Ice Age. A standard wooden torch, even under optimal conditions, produces light for perhaps 20 to 40 minutes and emits smoke that accumulates in confined spaces. In narrow cave passages with limited circulation, this smoke would quickly reduce visibility, contaminate breathable air, and leave behind detectable chemical residues. Experimental archaeology has shown that even short-term torch use in enclosed environments produces soot layers measurable in microns on nearby surfaces. Yet in Hoyo Negro, where multiple individuals would presumably need sustained illumination to travel hundreds of meters through darkness, the expected cumulative evidence is missing. One possible explanation is that the traces were erased over time, particularly after the cave flooded during the transition to the Holocene. Water movement, mineral deposition, and microbial activity could theoretically dissolve or obscure soot residues. However, this explanation is incomplete. The same mineral-rich conditions that might remove certain organic traces have also preserved Naya's skeleton in remarkable detail for over 12 millennia, along with the remains of extinct megafauna such as saber-toothed cats and giant ground sloths. If the environment is capable of preserving delicate bone structures, why would it selectively eliminate all evidence of fire-based lighting? The inconsistency suggests that either the evidence has not yet been found, or that the lighting methods used left far fewer traces than expected. This leads to more speculative, but increasingly discussed hypotheses. Could ancient explorers have used alternative light sources, materials that burn cleaner, produce less smoke, or leave minimal residue? Ethnographic studies of later human groups have documented the use of resin-rich woods, animal fats, and even early forms of oil lamps to produce more stable and controlled illumination. A fat-based lamp, for example, can burn for longer durations with reduced smoke compared to a simple torch, especially if shielded from airflow. Yet even these technologies typically leave behind residues, lipid traces, soot particles, or structural remains of containers. So far, no such artifacts have been conclusively identified in Hoyo Negro's accessible sections. Another possibility challenges our assumptions about human sensory adaptation. Some researchers have proposed that early humans navigating cave systems may have relied less on continuous illumination and more on intermittent light, combined with heightened spatial memory. In this model, small controlled light sources would be used sparingly, preserving fuel while minimizing environmental impact. Movement would occur in stages: illuminate, memorize, advance, and repeat, effectively turning the cave into a sequence of remembered segments rather than a continuously visible path. While plausible in theory, this approach demands an extraordinary level of cognitive mapping ability, especially in a three-dimensional environment filled with vertical shafts and branching corridors. Modern cave explorers, even with training, rely heavily on guidelines and external mapping tools to avoid disorientation. The idea that late Pleistocene humans could achieve similar feats with minimal lighting remains unproven, yet cannot be dismissed outright. Fieldwork conducted during multiple expeditions between 2007 and 2015 further complicates the picture. Divers mapping the Sakakton system noted that the routes leading to Hoyo Negro involve not only horizontal navigation but also vertical transitions, including steep inclines and drops that would have been hazardous without clear visibility. The entrance to the sinkhole itself is not immediately obvious. It opens suddenly beneath the cave floor, creating a lethal trap for anyone unaware of its presence. For Naya to have reached this point, whether by accident or intention, she would have needed to traverse a significant portion of the cave system first. This implies repeated access, familiarity with the environment, or guidance from others who had explored it before. None of these scenarios align easily with a model of sporadic, poorly lit exploration. Comparative analysis with other prehistoric cave sites reinforces the anomaly. In European Upper Paleolithic caves such as Lascaux or Chauvet, extensive evidence of human activity is accompanied by equally extensive evidence of lighting technology, torch marks, lamp fragments, and soot layers that map the movement of individuals through space. These sites demonstrate that when humans operated in darkness, they left behind a technological signature. Hoyo Negro, by contrast, represents the inverse, clear evidence of human presence with an almost complete absence of that signature. It is as if the act of illumination itself has been erased from the archaeological record. The implications extend beyond a single site. If the lighting technologies used in Hoyo Negro were fundamentally different, more efficient, less polluting, or based on materials that degrade without trace, then our current models of prehistoric technological capability may be incomplete. Alternatively, if the absence of evidence is due to preservation bias, then Hoyo Negro represents a cautionary example of how easily entire categories of ancient technology can disappear from the record under specific environmental conditions. In either case, the site forces a reconsideration of what we assume about the limits of early human engineering and adaptation. In the end, Hoyo Negro is not just a place where a young woman fell into darkness over 12,000 years ago. It is a place where our understanding of ancient technology itself begins to falter. The deeper researchers look, the more the silence of the cave becomes its most compelling feature, not the absence of answers, but the absence of the very traces we expect to find. And in that silence, one question continues to echo. If ancient humans could move through absolute darkness without leaving behind the evidence of how they did it, what else might they have known that we have yet to rediscover? Deep within the dense, rain-soaked forests of Sri Lanka's southwestern highlands lies Batad Lena Cave, a site that, at first glance, appears unremarkable. Just another limestone shelter carved by time and water. Yet beneath its quiet surface, this cave has revealed evidence that challenges one of the most fundamental assumptions about early human technology: that complexity evolved slowly and only in certain advanced regions of the prehistoric world. Excavations conducted throughout the late 20th century, most notably under the direction of archaeologist Sirandarani Agala, uncovered stratified deposits dating back approximately 36,000 years, firmly placing Batad Lena within the late Pleistocene. But it is not the age of the site that has captivated researchers. It is the astonishing sophistication of the tools found within it, particularly a class of artifacts known as microliths, which may represent one of the earliest examples of what could be described metaphorically as nano-engineering in human history. These microliths, often measuring no more than 1 to 3 centimeters in length, are not crude flakes or accidental byproducts of stone knapping. Instead, they exhibit consistent geometric shapes, triangles, crescents, trapezoids, with finely retouched edges and clear signs of deliberate shaping. The production of such tools requires an advanced understanding of fracture mechanics. The napper must control the angle, force, and point of impact with remarkable precision to detach tiny, predictable fragments from a core without shattering the entire piece. Experimental archaeology has shown that even skilled modern practitioners struggle to produce microliths with consistent size and symmetry, particularly when working with the types of raw materials available in tropical environments. And yet, at Batad Lena, hundreds, if not thousands, of these tools have been recovered, many displaying a level of standardization that implies not only skill, but a repeatable, possibly taught technique. What makes this even more extraordinary is the chronological context. In Europe, microlithic technologies are generally associated with the Mesolithic period, emerging widely after about 12,000 years ago as human groups adapted to post-glacial environments, and sites such as Hohlfels Cave provide evidence of early symbolic behavior and tool use, but the systematic production of microliths appears significantly later. In contrast, Batad Lena presents clear evidence of microlithic technology tens of thousands of years earlier, suggesting either an independent invention or a much earlier origin of this technological strategy than previously believed. Comparisons with Blombos Cave, another key site known for early advanced behavior, including engraved ochre and bone tools dating to around 75,000 years ago, highlight an important distinction. While Blombos demonstrates symbolic and possibly cognitive complexity, Batad Lena provides direct evidence of mechanical and functional precision at a miniature scale. The implications of this are profound, and microliths are rarely used alone. Their small size makes them inefficient as standalone tools. Instead, they are typically hafted, embedded into wooden or bone shafts using adhesives such as plant resins or animal glues to form composite tools like arrows, spears, or cutting implements. This means that the inhabitants of Batad Lena were not merely shaping stone, they were engineering multi-component systems, combining materials with different properties into a unified functional design. Such composite technology requires planning, foresight, and an understanding of how different elements interact under stress. It is, in essence, a form of systems engineering, appearing tens of thousands of years earlier than many models of human technological evolution would predict. Archaeological layers within the cave also contain faunal remains that support this interpretation. Bones of small, agile arboreal animals, monkeys, giant squirrels, and various bird species have been identified, indicating that the cave's inhabitants were successfully hunting in a dense tropical rainforest environment. This is significant because such environments present unique challenges: limited visibility, complex terrain, and fast-moving prey that often dwell in the canopy. Traditional large hunting weapons would be impractical here. Instead, lightweight, fast projectiles, potentially tipped with microliths, would offer a clear advantage. While direct evidence of bows has not survived, due to the rapid decomposition of organic materials in humid climates, the presence and morphology of the microliths strongly suggest their use in projectile technology. If true, this would push back the timeline for the development of advanced hunting systems by tens of thousands of years. Another layer of complexity emerges when considering the raw materials themselves. Geological analyses have indicated that some of the stone used to produce microliths at Batad Lena does not originate from the immediate vicinity of the cave. Instead, it appears to have been transported from sources located several tens of kilometers away. This raises critical questions about mobility and social interaction. Were these early humans traveling long distances through dense jungle to acquire specific types of stone? Or were they engaged in some form of exchange network with neighboring groups? Either scenario implies a level of spatial awareness, planning, and possibly even social organization that goes beyond the simplistic models often applied to Paleolithic societies. Equally puzzling is the preservation of these artifacts. Tropical environments are notoriously destructive to archaeological materials, especially organic components. High humidity, fluctuating temperatures, and biological activity typically accelerate decay. Yet the microliths at Batad Lena remain remarkably well defined, their edges still sharp, their shapes intact. This suggests that the inhabitants may have been selectively choosing raw materials with superior durability, or that the cave's microenvironment provided unusually stable conditions. Now, some researchers have even speculated, cautiously, that early humans may have possessed empirical knowledge of how different stones weather over time, effectively engaging in a rudimentary form of material science. Despite decades of research, many aspects of Batad Lena remain unresolved. There is no clear consensus on whether the microlithic technology developed here independently or represents part of a broader, yet poorly understood network of technological exchange across prehistoric Asia. Nor is it fully understood how such a high level of precision was achieved without metal tools, advanced measuring instruments, or written knowledge systems. What is clear, however, is that the people who inhabited this cave were not merely surviving. They were innovating, experimenting, and refining techniques in ways that blur the line between primitive and advanced. If humans over 30,000 years ago were already capable of creating nano-level technology like microliths, how much do you think we've underestimated their intelligence? Share your thoughts in the comments below. Deep within the limestone ridges of the Harz Mountains in Germany lies Einhorn, a cave whose name, Unicorn Cave, originated from medieval misconceptions, yet whose true significance may be far more unsettling than myth. For centuries, scholars and treasure hunters alike were drawn to this site, convinced that the scattered bones found within belonged to legendary creatures. But as systematic excavations began in the 19th century and continued through the 20th and 21st, a far more complex picture emerged. The cave contains the remains of more than 30 species of Ice Age animals, including cave bears, woolly rhinoceroses, and mammoths, alongside unmistakable evidence of both Neanderthal and early Homo sapiens activity. Yet what transforms Einhorn from a paleontological archive into a genuine archaeological mystery is not merely the presence of these bones, but the way they have been preserved, arranged, and altered in ways that challenge conventional scientific explanations, particularly when examined through the lens of what can only be described as illogical preservation. Excavations conducted by German research teams in recent decades, including interdisciplinary studies combining archaeology, geochemistry, and taphonomy, have revealed that many of the bones within Einhorn display a level of preservation that appears inconsistent with standard models of decomposition. Under typical cave conditions, even in stable environments, organic material undergoes gradual mineral replacement, fragmentation, and microbial degradation. In comparable European cave systems such as Chauvet Cave in France or Denisovan Cave in Siberia, bones dating back tens of thousands of years often show clear signs of weathering, surface erosion, and biochemical alteration. Yet in Einhorn certain specimens, some dated to over 50,000 years, retain structural integrity and surface detail at levels that appear anomalously high. Microscopic analysis has shown that collagen traces, which typically degrade rapidly over such timescales, are sometimes preserved in measurable quantities, raising questions about the environmental or possibly artificial factors involved. One of the central puzzles lies in the inconsistency of preservation within the same microenvironment. In some chambers of the cave, bones are heavily degraded, fragmented, and chemically altered, consistent with expectations. Yet only meters away, other remains, belonging to the same species and presumed to be of similar age, appear remarkably intact, with minimal signs of microbial activity or mineral intrusion. This uneven preservation defies the assumption that cave microclimates operate uniformly over small spatial scales. Geological surveys of Einhorn have identified variations in humidity, airflow, and mineral composition, particularly in areas rich in calcium carbonate deposits. These factors can indeed slow decomposition, as calcite layers may encase organic material and shield it from bacteria. However, the degree of preservation observed in some cases exceeds what such natural processes alone would predict, especially when compared to controlled experimental models of fossilization. Adding to the mystery are indications that some bones may have undergone forms of surface modification prior to their long-term preservation. Archaeologists have documented cut marks, polishing patterns, and thermal alterations on certain specimens, suggesting that they were handled, processed, or even deliberately treated by human or Neanderthal inhabitants. In one particularly significant discovery reported in 2023, researchers identified a structured arrangement of large animal bones interpreted as a Neanderthal constructed feature dated to approximately 51,000 years ago. While the structure itself points to advanced spatial organization and symbolic behavior, The condition of the bones used in its construction raises further questions. Many of these elements show a resistance to decay that seems disproportionate to their age and exposure history, prompting speculation that they may have been subjected to processes, intentional or incidental, that enhance their durability. Comparative analysis with other Paleolithic sites strengthens the enigma. At Denisovan Cave, for instance, despite similarly cold and stable conditions, bone preservation varies but rarely reaches the level of consistency seen in the best preserved samples from Einhorn. Likewise, in Hoyo Cave, while cave art has survived due to stable environmental conditions, associated organic remains do not exhibit the same anomalous resistance to degradation. This suggests that Einhorn may possess a unique combination of environmental variables, or that its ancient inhabitants engaged in behaviors that inadvertently or deliberately influenced preservation outcomes. Some researchers have proposed that the repeated use of fire within specific chambers could have altered the chemical composition of bone surfaces, creating a form of primitive thermal stabilization. Others have pointed to the possibility of mineral-rich water interacting with organic material in ways that accelerated partial fossilization, effectively locking in structural features before decay could proceed. Yet even these hypotheses struggle to fully account for the observed data. If mineral deposition were the primary factor, one would expect a more uniform distribution of preservation across similarly exposed remains. If thermal alteration were responsible, consistent burn patterns or residues would be evident across all well-preserved samples. Instead, what emerges is a pattern that appears selective, almost curated. Certain bones preserved in exceptional condition, others left to decay, without an immediately obvious natural explanation. This has led some archaeologists to cautiously entertain the idea that prehistoric humans or Neanderthals may have engaged in forms of material handling that, while not technology in the modern sense, nonetheless reflect an intuitive understanding of how to manipulate environmental factors to achieve specific outcomes. The broader implications of this are profound. If the inhabitants of Einhorn were capable of influencing the preservation of organic material, whether through placement, exposure to mineral-rich surfaces, or controlled use of fire, then we may be looking at an early form of applied knowledge that borders on proto-technology. Not technology as a set of tools, but as a system of interactions between material, environment, and intention. Such a perspective aligns with emerging views of Neanderthal cognition, which increasingly emphasize their capacity for abstract thought, planning, and symbolic behavior. The cave, in this sense, becomes not just a shelter or a storage site, but a controlled environment, an experimental space where organic matter was processed, arranged, and perhaps even preserved, with a purpose that remains elusive. Despite more than a century of investigation, Einhorn continues to resist definitive interpretation. Each new excavation, each layer of sediment carefully removed, reveals new data points, but also deepens the central mystery. Radiocarbon dating, isotopic analysis, and advanced imaging techniques have refined our understanding of chronology and composition. Yet they have not resolved the question of why certain bones have endured in such extraordinary condition, while others have not. The cave stands as a reminder that preservation itself can be as enigmatic as destruction, that what survives the passage of tens of thousands of years may do so not only because of where it lies, but because of how it was treated long before it became a fossil. In the end, Einhorn challenges one of archaeology's most fundamental assumptions, that the past is passively recorded in the material remains we uncover. Here, the evidence suggests something more active, more intentional. Whether the result of unique geological conditions or a forgotten form of human interaction with the environment, the illogical preservation of bones within this cave forces us to reconsider the boundaries between natural process and ancient ingenuity. And in doing so, it leaves us with a question that lingers long after the data has been analysed. Were these bones simply preserved? Or were they, in some way we have yet to understand, made to endure? Hidden within the desolate expanse of the Great Basin in western Nevada, Spirit Cave stands as one of the most quietly disruptive archaeological sites in North America, a place where fragile strands of plant fiber challenge everything we thought we understood about prehistoric technology. First excavated in 1940 by Sidney M. Wheeler, the cave initially gained attention for the discovery of a remarkably well-preserved human mummy, later dated to approximately 10,600 years before present through radiocarbon analysis. Yet as subsequent expeditions revisited the site, particularly in the 1970s with improved stratigraphic methods, in the 1990s with refined carbon dating, and again in the 2010s using advanced material analysis, the true significance of Spirit Cave began to shift away from the human remains themselves and towards something far more subtle, yet arguably more profound: the textiles, sandals, and woven artifacts that accompanied them. These items, crafted from processed sagebrush bark and other native plant fibers, have been dated to roughly the same period, placing them among the oldest surviving examples of fiber technology in the Americas and possibly the world. What makes them extraordinary is not merely their age, but the level of technical precision embedded in their construction, a precision that seems almost anachronistic when placed within the broader context of early Holocene hunter-gatherer societies. The sandals recovered from the cave, for instance, are constructed using a sophisticated twining technique in which two or more weft elements are systematically twisted around a series of warp elements, creating a flexible yet highly durable structure. Microscopic analysis has revealed that the fibers were not randomly assembled but processed to achieve consistent thickness and tensile strength, with twist angles maintained at near uniform degrees across entire sections of the weave. In some cases, the spacing between strands remains consistent within a fraction of a millimeter, suggesting not only skilled craftsmanship, but an internalized standard of production, something closer to an unwritten engineering protocol than ad hoc experimentation. Experimental reconstructions conducted by modern researchers have demonstrated that reproducing these sandals using only primitive tools requires dozens of hours of labor and a deep familiarity with the mechanical behavior of plant fibers, including their response to moisture, tension, and repeated stress. When compared to early textile traditions in other parts of the world, the implications become even more striking. At sites like Çatalhöyük, widely regarded as one of the earliest centers of complex human settlement, evidence of woven textiles appears around 7000 BCE, several millennia after the Spirit Cave artifacts, yet often in less structurally refined forms. Similarly, early Neolithic sites in the Levant and Mesopotamia show the gradual emergence of weaving technologies alongside the development of agriculture and sedentary life, reinforcing the long-held assumption that complex textile production is a byproduct of stable, resource-rich societies. Spirit Cave, however, disrupts this narrative entirely. Here, in a harsh, resource-scarce desert environment inhabited by mobile hunter-gatherers, we find fiber technologies that not only rival, but in some respects exceed those of later agricultural communities. This raises a fundamental question. How did such a high level of material engineering emerge in a context where, according to conventional models, it should not exist? The answer may lie in the unique environmental pressures of the Great Basin. With extreme temperature fluctuations, near limited water sources, and a landscape that offers little margin for error, survival would have depended on tools and materials that were both lightweight and exceptionally durable. In this context, the development of advanced fiber technologies may represent a form of adaptive innovation, a response to environmental constraints that drove experimentation and refinement over countless generations. Yet even this explanation falls short of accounting for the apparent standardization observed in the artifacts. The repeated patterns, consistent techniques, and uniform quality suggest not isolated ingenuity, but a shared body of knowledge, transmitted and preserved within the community with remarkable fidelity. Without written language, this transmission would have relied on oral instruction and hands-on apprenticeship, raising the possibility that prehistoric societies possessed far more sophisticated systems of knowledge preservation than we typically acknowledge. Further complicating the picture is the role these textiles may have played beyond mere utility. The Spirit Cave mummy itself was found wrapped in layers of woven material, arranged in a manner that appears deliberate rather than incidental. Some researchers have proposed that these wrappings were designed not only for cultural or ritual purposes, but also to regulate the microenvironment around the body, controlling airflow, reducing moisture, and inhibiting microbial activity. If true, this would imply an empirical understanding of how organic materials interact with environmental conditions, effectively representing an early form of biomaterial engineering. And such a possibility is supported by the exceptional state of preservation observed in both the mummy and the associated artifacts, which show minimal signs of decay despite their immense age. Modern analytical techniques, including scanning, electron microscopy, and chemical residue analysis, have begun to explore whether the fibers were treated with natural compounds, such as plant resins or ash solutions, to enhance their durability or resistance to pests. While definitive conclusions remain elusive, preliminary findings suggest that at least some level of material processing may have been involved, hinting at a proto-chemical approach to textile production. When viewed in this light, the artifacts of Spirit Cave are no longer simple remnants of daily life, but components of a broader technological system, one that integrates material science, environmental adaptation, and cultural practice into a cohesive whole. And yet, perhaps the most perplexing aspect of this system is its apparent disappearance. Despite the sophistication evident in the Spirit Cave materials, similar techniques do not appear to persist in a continuous, traceable lineage within the archaeological record of North America. Later cultures in the region exhibit their own forms of fiber technology, but often with different methods, materials, and levels of refinement, suggesting either a loss of knowledge or a transformation so complete that its origins become unrecognizable. Yet this discontinuity challenges the idea that technology evolves in a straight line, suggesting that entire bodies of ancient knowledge may have emerged and disappeared without leaving clear traces. Spirit Cave therefore acts both as a window into the past and a warning that what archaeology preserves is only a small fragment of true history. The woven artifacts found inside are not just objects, but evidence of a sophisticated and forgotten knowledge system, proving that prehistoric humans may have reached levels of technical mastery far beyond what we once believed. And the lingering question remains, how many ancient technologies have been lost simply because they were never carved in stone? If such advanced textile and material technologies existed over 10,000 years ago and then almost completely disappeared, how many other ancient technologies might we have never discovered? Share your thoughts in the comments below. Perched above the windswept coastline of southern Africa, Blombos Cave has quietly forced archaeologists to confront a deeply unsettling possibility. That complex technological thinking, once believed to belong to relatively recent civilizations, may have emerged tens of thousands of years earlier than expected, only to vanish and reappear much later in human history. Discovered in the early 1990s and extensively excavated beginning in 1991 under the direction of archaeologist Christopher Henshelwood, the cave has yielded a series of findings dated between approximately 70,000 and 100,000 years ago, pushing the boundaries of what is considered possible for early Homo sapiens. Among its most astonishing discoveries are engraved ochre fragments bearing deliberate geometric patterns, and are carefully perforated shell beads likely used as personal ornaments, and, most controversially, what appears to be a fully developed ochre processing workshop, a system so methodical that many researchers now describe it as one of the earliest known examples of chemical technology. At the centre of this mystery lies a set of artifacts uncovered in layers dated to roughly 100,000 years ago. 2 abalone shells used as containers, each containing a reddish compound composed of finely ground ochre mixed with crushed bone, charcoal, and a liquid medium believed to be animal fat or marrow. Accompanying these were hammerstones, grindstones, and bone tools stained with pigment, suggesting not a random accumulation of materials but a deliberate multi-step production process. What makes this discovery extraordinary is not merely the presence of pigment. After all, ochre use has been documented in other Middle Stone Age sites, but the clear evidence of systematic preparation. The ochre was not simply collected and applied, it was processed, combined with other substances, and stored for later use. This implies a level of planning, material knowledge, and procedural consistency that resembles a primitive form of chemical engineering. To understand how unusual this is, it is essential to compare Blombos Cave with other known archaeological contexts. In many early human sites, ochre appears as isolated fragments, often showing signs of scraping or grinding, suggesting its use as a colouring agent or symbolic material. However, these instances rarely demonstrate the full chaîne opératoire, the complete operational sequence, from raw material acquisition to final product storage. At Blombos, by contrast, researchers identified a coherent toolkit and spatial organisation that together indicate a structured production system. The presence of abalone shells as mixing vessels is particularly significant. These shells, with their natural concave shape and durability, functioned effectively as containers, allowing for the mixing and preservation of the pigment mixture. This is not an improvised solution. It reflects an understanding of material properties and functional design. Even more striking is the composition of the pigment itself. Experimental archaeology has shown that combining ochre with fat or marrow creates a more stable and adhesive substance, is suitable for application to skin, objects, or possibly cave surfaces. The addition of crushed bone may have altered the texture or consistency, while charcoal could have influenced the colour or chemical behaviour of the mixture. Such combinations suggest that the inhabitants of Blombos Cave were not merely using natural resources, but actively modifying them to achieve desired outcomes. This is a hallmark of technological behaviour, one that requires not only manual skill, but also cognitive abilities such as foresight, experimentation, and the transmission of knowledge across individuals or generations. When placed within a broader timeline, the implications become even more profound. Comparable evidence of pigment processing and storage does not appear again in the archaeological record until much later periods, and particularly during the Upper Paleolithic, around 40,000 years ago, when cave art flourished in Europe. Even then, while pigment preparation is evident, the level of organisation seen at Blombos remains exceptional. If we look further ahead to ancient civilizations such as Egypt, around 3,000 years before the Common Era, we find highly sophisticated pigment technologies, including the production of Egyptian blue, a synthetic pigment requiring controlled heating and precise chemical ratios. Yet the gap between Blombos and these later developments spans tens of thousands of years, raising a critical question. Why does such an advanced system appear so early? And why is there so little evidence of its continuous development? Excavations conducted between 1991 and 2011 have reinforced the interpretation of Blombos as a site of repeated, organised activity rather than a one-time occupation. Stratigraphic analysis reveals multiple occupation layers, each containing variations of similar tools and materials, suggesting that the pigment production process was not an isolated experiment, but a recurring practice. Radiometric dating techniques, including optically stimulated luminescence, have consistently placed these activities within the same general time frame, lending credibility to the notion that this technological behavior persisted over generations. Furthermore, microscopic analysis of the tools has identified wear patterns consistent with grinding and mixing, while residue analysis confirms the presence of ochre-based compounds. Despite this wealth of evidence, significant questions remain unresolved. One of the most puzzling aspects is the purpose of the pigment. While it is often assumed that ochre was used for symbolic or decorative purposes, such as body painting or ritual marking, there is no direct evidence linking the Blombos mixture to specific applications. Could it have been used as an adhesive, perhaps in toolmaking or hafting? Some researchers have proposed this possibility, noting that ochre-based compounds can enhance the binding properties of natural glues. However, the exact formulation found at Blombos does not perfectly match known adhesive recipes, leaving the question open. Alternatively, the pigment may have served multiple functions, indeed combining practical and symbolic roles in ways that are difficult to disentangle. Another unresolved issue concerns the origin of the knowledge required to produce such mixtures. The process involves several steps: selecting appropriate raw materials, grinding them to the correct consistency, combining them in specific proportions, and storing the result in suitable containers. Each of these steps requires not only individual skill, but also an understanding of cause and effect, knowledge that must have been acquired through repeated experimentation or passed down through social learning. Yet the archaeological record offers little insight into how this knowledge was developed or transmitted. There are no written records, no direct evidence of teaching, and no clear evolutionary pathway leading to this level of sophistication. This has led some scholars to propose that Blombos represents a localized innovation hotspot, where unique environmental or social conditions allowed for a temporary leap in technological complexity. The comparison with other Middle Stone Age sites further highlights the uniqueness of Blombos. Sites such as Pinnacle Point, also in South Africa, show evidence of early ochre use and heat treatment of stone tools, indicating advanced cognitive behavior. However, even in these contexts, the kind of integrated multi-component production system seen at Blombos is rare. In Europe and Asia, similar developments appear much later, often associated with the spread of modern humans and the emergence of symbolic culture. This raises the possibility that the behaviors observed at Blombos were not widely shared, or did not persist long enough to influence broader human populations. What do you think? Was the paint workshop at Blombos Cave a forgotten breakthrough, or evidence of an ancient knowledge system we still don't fully understand? Share your thoughts in the comments below. On a rugged limestone cliff along the Gower Peninsula in southern Wales, Paviland Cave, often called Goat's Hole, opens toward the sea like any ordinary coastal cave. Yet what was uncovered inside has challenged over 2 centuries of archaeological assumptions. When William Buckland first excavated the site in 1823, he believed he discovered the remains of a Roman-era woman, surrounded by ornaments and stained with red pigment, leading him to name the figure the Red Lady. That interpretation would later collapse under modern scientific scrutiny. Radiocarbon dating and stratigraphic reanalysis carried out in the 20th century revealed that the skeleton belonged not to a Roman individual nor even to a woman, but to a male human who lived approximately 33,000 years ago during the Upper Paleolithic, a time when Britain was locked in the grip of the last ice age. Yet the real enigma of Paviland is not the identity of the burial, but the astonishing level of craftsmanship represented by the objects placed alongside it, particularly the ivory ornaments that seem to exist far beyond the technological expectations of their era. The burial itself was clearly intentional. The body had been carefully positioned and covered with red ochre, a mineral pigment rich in iron oxide that had to be deliberately sourced, processed, and applied. Surrounding the remains were decorative artifacts including perforated marine shells transported from distant coastal areas and, most intriguingly, ornaments made from mammoth ivory. These ivory objects are not crude fragments. They're shaped, polished, and in several cases drilled with clean, symmetrical perforations that strongly suggest controlled, repeatable techniques. This is where the mystery deepens. Mammoth ivory is a notoriously difficult material to work with. Its internal structure consists of layered dentin with natural grain patterns that make it highly susceptible to cracking under uneven pressure. Even with modern tools, carving and drilling ivory without causing fractures requires careful control of force, angle, and temperature. Yet at Paviland, these constraints appear to have been overcome using only Stone Age technology. Experimental archaeology offers partial insight, yet it also reveals just how challenging this process truly was. Researchers attempting to recreate Upper Paleolithic ivory working techniques have relied on flint tools, bone awls, and primitive bow drill systems combined with abrasive materials such as fine sand. These experiments demonstrate that it is theoretically possible to produce small perforations in ivory through rotational drilling, especially when drilling from both sides toward the center, a method that reduces stress and helps prevent cracking. However, the process is extremely time-consuming. Crafting a single bead with a smooth surface and a clean hole can require several hours or even days of continuous effort. The beads discovered at Paviland, although limited in number, display a level of precision and consistency that suggests not random experimentation, but a refined and possibly transmitted skill. The symmetry of the perforations and the polished surfaces indicate that these artisans were not improvising. They were applying a deliberate and repeatable technique. This raises a critical contradiction. The individual buried at Paviland lived in an environment characterized by extreme cold, limited vegetation, and the constant need for mobility in pursuit of migrating herds. Survival would have required efficiency, adaptability, and a focus on immediate needs such as food, shelter, and protection. In such a context, the investment of significant time and effort into the creation of decorative ivory objects appears irrational, unless these objects served a purpose beyond the material. Their presence in a burial context suggests that they were not utilitarian tools, but symbolic items, possibly linked to identity, status, or belief systems. In other words, the technology involved in their creation cannot be separated from the cognitive framework that produced them. Comparative evidence from other Upper Paleolithic sites reinforces both the possibility and the mystery of such craftsmanship. At Hoyo Cave, archaeologists have uncovered ivory figurines dating to roughly 40,000 years ago, including the famous Venus sculpture, which exhibits deliberate shaping and fine detail. At Magura Cave, flutes carved from bird bone and mammoth ivory have been found, with precisely spaced finger holes that suggest an understanding of acoustic principles. Meanwhile, at Blombos Cave, evidence dating back nearly 100,000 years indicates the deliberate processing of ochre and the creation of engraved geometric patterns. These sites collectively demonstrate that early humans were capable of sophisticated material manipulation and symbolic behavior across different regions and time periods. However, they also highlight a persistent gap in our understanding. While we can observe the results, we struggle to reconstruct the processes and knowledge systems that made them possible. At Paviland, subsequent excavations and analyses have added important data points. 20th century investigations, along with more recent work involving researchers from institutions such as the Natural History Museum, have confirmed the integrity of the burial context and refined its dating. The artifacts are not intrusive. They belong to the same temporal layer as the skeleton. This eliminates the possibility that the ivory ornaments were introduced at a later time. Furthermore, the presence of marine shells indicates long-distance movement or exchange networks, suggesting that the group responsible for the burial was not isolated. They were part of a broader human landscape in which ideas, materials, and perhaps techniques could circulate. Yet even with this broader context, the technical challenge of working mammoth ivory remains difficult to explain in practical terms. One hypothesis is that what we are observing is a form of invisible technology, a body of knowledge that does not leave behind durable traces in the archaeological record. This could include techniques such as controlled abrasion, using progressively finer materials, the use of organic lubricants to reduce friction during drilling, or even simple yet effective mechanical systems like bow drills that amplify rotational motion. Such methods would rely heavily on skill, experience, and oral transmission rather than on permanent tools or written instructions. Over thousands of years, this knowledge could have been refined and standardized within small groups, only to disappear later without leaving a clear record. In this sense, the ivory ornaments at Paviland are not just objects. They are the residual evidence of a technological tradition that has largely vanished. Ultimately, Paviland Cave is a paradox, a place where physical evidence reveals capabilities far beyond its time. The ivory ornaments demonstrate precision without metal and sophistication without industry, forcing us to question the assumed path of human technological development. If this is true, then the issue is not just how these objects were made, but how much knowledge has been lost over time, leaving behind only silent fragments of ivory that continue to challenge every explanation. If humans over 33,000 years ago were already capable of crafting ivory with such astonishing precision, could there have been other ancient technologies that were once highly advanced, but have completely disappeared without a trace? Share your thoughts in the comments below. The desert landscapes of Central Asia hold many archaeological sites connected to the ancient Silk Road, but few are as intriguing and mysterious as the Karateepe cave temples, located near the city of Termes in modern-day Uzbekistan. Carved into low hills overlooking the Amu Darya River, this ancient complex dates back roughly to the first centuries of the Common Era, during the time of the Kushan Empire. At first glance, Karateepe may appear to be simply another Buddhist monastic settlement, yet closer examination reveals something far more remarkable. The site presents an unusual convergence of artistic traditions, architectural influences, and religious imagery from multiple civilizations. Even more mysterious are the traces of wall paintings and sculptures that once covered the cave interiors, suggesting that these chambers were once vibrant spiritual spaces filled with color and symbolism. Together, these elements raise fascinating questions about cultural exchange, artistic transmission, and the complex networks that connected distant regions of the ancient world. One of the most striking aspects of Karateepe is the unusual mixture of cultural influences preserved in its architecture and artistic fragments. Archaeologists studying the site have noted that many features of the complex resemble Buddhist monasteries found much farther south in regions such as northern India and Afghanistan. The layout includes meditation cells, small shrines, and courtyard-like spaces that appear to follow traditional monastic planning associated with early Buddhist communities. However, the decorative and artistic elements discovered here tell a far more complicated story. Among the fragments found within the caves are sculptures and relief pieces that display stylistic features closely related to the Gandhara artistic tradition, a cultural blend that itself combined Indian religious themes with the sculptural realism of the Greco-Roman world. This style is most recognizable in the depiction of Buddha figures with flowing robes, carefully modeled faces, and naturalistic proportions reminiscent of classical Mediterranean sculpture. The presence of such imagery in Central Asia immediately suggests that Karateepe stood at an important crossroads of civilizations. During the Huashan period, vast trade routes connected India, Persia, China, and the Mediterranean through the Silk Road. Merchants, pilgrims, artisans, and scholars travelled across these routes carrying not only goods but also artistic techniques, religious ideas, and architectural knowledge. Karateepe appears to have been one of the locations where these influences converged. Some fragments of sculpture display delicate folds of clothing and body proportions similar to statues found in ancient Gandhara, while other elements hint at decorative traditions associated with Iranian and Central Asian cultures. In certain carvings, the treatment of facial features and ornamental details appears subtly different from the classical Gandharan style, suggesting that local artists may have adapted foreign artistic traditions into their own regional forms. This blending of styles raises an intriguing historical puzzle. How did such a remote monastic complex become a place where artistic traditions from several distant civilizations intersected? One explanation lies in the extraordinary mobility of artisans and craftsmen along the Silk Road. Workshops and artistic schools did not exist in isolation. Instead, techniques were passed from region to region through apprenticeship, trade networks, and travelling religious communities. Buddhist monks themselves often served as cultural transmitters, bringing texts, images, and iconographic traditions with them as they moved between monasteries. Karateepe may therefore represent not a single artistic tradition, but rather a living cultural experiment where influences from India, Hellenistic territories, and Central Asia were gradually fused into a unique visual language. Equally fascinating are the remains of the wall decorations that once covered the interiors of many caves. Although time has erased most of the original imagery, archaeologists have discovered fragments of plaster and pigment that confirm the caves were once painted extensively. These traces suggest that the walls may have been decorated with scenes from Buddhist teachings, symbolic motifs, and possibly images of monks or donors. In their original state, these paintings likely transformed the austere stone chambers into vibrant ceremonial spaces filled with colour and narrative imagery. The presence of painted surfaces indicates that the caves were not merely places for meditation, but also served as ritual environments designed to inspire devotion and contemplation. Some surviving fragments hint at the complexity of these lost murals. Small sections of painted plaster reveal the use of red, ochre, and other mineral pigments applied carefully onto prepared surfaces. The artistic techniques appear similar to those found in other Buddhist cave complexes across Asia, such as those in Afghanistan and Western China. Yet the fragments from Karateepe are often too incomplete to reconstruct the full scenes they once belonged to. This partial survival leaves modern researchers with only glimpses of the original visual program that once adorned the temple interiors. Alongside the paintings, archaeologists also uncovered numerous pieces of sculptural decoration, broken statues, relief fragments, and small decorative elements suggest that many caves contained carefully arranged altars and shrines. Some of these sculptures depict Buddhist figures, while others appear to represent symbolic motifs associated with religious practice. The statues were often made from clay or stucco rather than solid stone, allowing artisans to create intricate details and expressive forms. These materials, however, are far more vulnerable to erosion and damage than stone, which explains why many of the original sculptures survive only in fragments today. The The combination of painted walls and sculptural decoration suggests that Karateepe was once far more visually elaborate than the bare ruins visible today. When the monastery was active, visitors entering the caves would likely have encountered spaces filled with imagery, painted figures emerging from brightly coloured walls, statues positioned in niches, and possibly ceremonial objects placed within shrines. The artistic environment would have played an important role in guiding meditation and reinforcing the teachings of Buddhism through visual storytelling. Yet despite the clues provided by these fragments, many mysteries remain. Because so much of the decoration has been lost, researchers cannot fully reconstruct the themes or narratives that once dominated the murals. Were they primarily scenes from the life of the Buddha, symbolic cosmological diagrams, or portraits of patrons who supported the monastery? The limited evidence leaves room for multiple interpretations. In some cases, even the stylistic origins of certain fragments are difficult to determine, raising the possibility that Karateepe's artists experimented with new visual approaches that differed from those used elsewhere along the Silk Road. The disappearance of most of the paintings and sculptures adds another layer of mystery to the site. Over centuries, environmental factors such as wind, moisture, and temperature changes gradually damage the fragile surfaces inside the caves. Human activity may also have contributed to the destruction, whether through abandonment, conflict, or the reuse of materials in later periods. As a result, modern visitors encounter only faint traces of what was once a richly decorated monastic environment. Today, Karateepe stands as a silent witness to an extraordinary period of cultural interaction in ancient Central Asia. The caves carved into its hills preserve the architectural framework of a Buddhist monastery, but the artistic fragments scattered throughout the site reveal something far more complex. They speak of a place where artistic traditions from India, the Hellenistic world, and Central Asia met and blended in unexpected ways. They also hint at a lost visual world of painted walls and sculpted figures that once transformed these caves into sacred spaces of colour and symbolism. For historians and archaeologists, Karateepe raises an enduring question. How many other cultural crossroads like this existed along the Silk Road, now lost or only partially preserved beneath centuries of erosion and silence? The fragments of art and architecture that survive here offer only a small window into a much larger story of ancient connectivity. And while the original murals and statues may never be fully recovered, the mysteries they leave behind continue to remind us that the ancient world was far more interconnected, creative, and culturally dynamic than we often imagine. The ancient world is filled with monuments carved from stone, temples raised from desert sands, and cities built by civilizations long vanished. Yet few places blur the boundary between natural landscape and sacred architecture as completely as the cave temples of Dambula Cave Temple in Sri Lanka. Perched high on a massive granite outcrop that rises more than 100 meters above the surrounding plains, this extraordinary complex represents one of the longest continuously used sacred sites on Earth. For over 2,000 years, monks, kings, artisans, and pilgrims have entered these caves, transforming what were once simple natural hollows in the rock into an immense underground sanctuary. The result is a place where nature and human engineering merge so seamlessly that it can be difficult to tell where the mountain ends and the temple begins. The story of Dambula begins in the 1st century BCE, during a period of political turmoil in ancient Sri Lanka. According to historical chronicles, a king named Valagamba sought refuge in these caves after being forced from his throne. Hidden among the cliffs and forests of the region, the caves provided shelter and protection. When the king eventually regained power, he returned to the site not merely to thank the monks who had protected him, but to transform the caves into a monumental sanctuary dedicated to the Buddha. Over the centuries that followed, successive rulers expanded and embellished the complex, carving statues, smoothing walls, and covering vast surfaces of stone with sacred paintings. Today, the Dambula complex contains 5 major caves and several smaller chambers, together forming a sacred space that stretches across more than 2,000 square meters. What makes this site particularly mysterious is not simply its size, but the astonishing way in which natural geology was reshaped into a carefully organized religious environment. Instead of building temples from quarried stone blocks, the ancient builders chose a far more difficult path. They adapted the interior of the mountain itself. The caves were not empty spaces waiting to be decorated. They were irregular, dark, and uneven rock chambers that had to be transformed through careful carving, smoothing, and engineering. Inside these caves, the rock walls were gradually flattened and shaped into surfaces suitable for sculpture and painting. Massive statues of the Buddha were carved directly from the living rock, some stretching more than 15 meters in length. Other statues were created from brick and plaster, then carefully painted and gilded to blend with the stone surroundings. Over time, the caves became filled with more than 150 statues, arranged in complex patterns that reflect centuries of religious devotion and artistic tradition. Standing inside the chambers today, visitors find themselves surrounded by rows of serene figures illuminated by dim light, their golden surfaces glowing against the dark stone of the mountain. Yet perhaps the most extraordinary feature of the caves lies above the statues rather than beside them. The ceilings and upper walls of the chambers are almost completely covered in ancient murals. These paintings depict scenes from the life of the Buddha, celestial beings, royal patrons, and symbolic patterns that seem to ripple across the stone like waves. In total, the murals cover thousands of square meters, forming one of the largest continuous collections of ancient Buddhist painting in the world. What is particularly astonishing is how well many of these paintings have survived. Despite centuries of humidity, heat, and human presence, their colors remain vivid, suggesting that the artist who created them possessed sophisticated knowledge of mineral pigments and binding materials. But preserving delicate artwork inside a tropical cave environment required more than artistic skill. It required engineering. One of the most intriguing and often overlooked aspects of the Dambula caves is an ancient system designed to control rainwater flowing down the mountain's surface. During the monsoon season, enormous amounts of water cascade down the granite cliffs above the caves. Without protection, this water would seep into the chambers, dripping onto statues and murals, slowly eroding centuries of art. To prevent this, the ancient builders carved a narrow groove into the rock face above the entrances of the caves. This feature, often called a drip line, runs horizontally along the cliff just above the cave openings. Although it appears simple at first glance, the groove performs an extremely important function. When rainwater flows down the rock surface, it reaches the carved channel and is redirected away from the cave entrances. Instead of dripping into the sacred chambers, the water follows the groove and falls harmlessly away from the walls below. What makes this system remarkable is the precision with which it was cut. Granite is one of the hardest natural stones, yet the groove was carved cleanly and consistently along the entire length of the rock face. In many places, the channel maintains a uniform depth and angle, ensuring that water cannot bypass the system even during heavy storms. This suggests that the builders possessed not only tools capable of shaping extremely hard stone, but also a practical understanding of how water behaves on sloping rock surfaces. Without this ancient drainage system, it is possible that the murals inside the caves would have been destroyed centuries ago. The drip line acts as a silent guardian of the temple's interior, protecting fragile artwork from the relentless forces of nature. In a sense, the survival of Dambula's paintings and statues may depend as much on this simple, carved groove as on the artistic talents of the monks and craftsmen who decorated the caves. The combination of natural caves, monumental sculpture, sacred painting and subtle engineering creates an environment unlike almost any other ancient religious site. Unlike temples built in open landscapes, the Dambula sanctuary feels hidden within the mountain itself. The thick stone walls insulate the chambers from the outside world, while narrow entrances allow beams of sunlight to filter into the darkness, illuminating statues that have remained in silent meditation for centuries. For archaeologists and historians, the caves raise fascinating questions about the capabilities of ancient builders. How were such large statues carved inside confined rock chambers? What tools were used to smooth the stone surfaces before painting? And how did ancient engineers develop a drainage system precise enough to protect delicate murals for thousands of years? Even today, many of these questions remain partly unanswered. While researchers understand the general techniques used in ancient stone carving, the scale and refinement of the work inside Dambula continue to impress specialists who study early Buddhist architecture. The caves demonstrate that ancient craftsmen were not merely decorators of sacred spaces. They were engineers capable of reshaping entire landscapes to serve spiritual purposes. More than 2 millennia after the first monks settled here, the Dambula caves still function as a place of worship. Pilgrims climb the stone steps leading up the granite hill, just as travelers did centuries ago. Inside the cool darkness of the chambers, the statues remain in their quiet rows, while the painted ceilings continue to tell stories that began thousands of years in the past. In many ways, the true mystery of Dambula is not a hidden artifact or lost inscription. It is the extraordinary collaboration between nature and human ingenuity. A mountain became a temple, rainwater became part of a carefully controlled system, and simple caves became one of the most remarkable sacred complexes in the ancient world. Hidden within the forested hills of southern India lies a cave that has puzzled archaeologists, historians, and explorers for decades. High in the Western Ghats mountain range, inside the rugged landscape of Wayanad in Kerala, the Edakal cave petroglyphs preserve a collection of ancient carvings unlike almost anything else discovered in the region. At first glance, the cave appears unremarkable, a narrow rocky chamber formed when a massive boulder became wedged between two cliffs thousands of years ago. But once inside, the stone walls reveal a dense network of carvings that seem to whisper fragments of a forgotten past. These engravings, etched directly into the rock surface, form one of the most mysterious archaeological records in South Asia. Their age, their purpose, and even the identity of the people who created them remain subjects of intense debate. What makes Edakal truly extraordinary is not just the presence of ancient carvings, but the complexity and diversity of the symbols themselves, suggesting that the cave may have served as a place of communication, ritual, or cultural memory across thousands of years. Many researchers believe that some of the carvings found inside the cave may date back between 6,000 and 8,000 years, placing them deep within the prehistoric period. If this estimation is correct, the Edakal engravings would belong to a time when early human communities were still transitioning from nomadic lifestyles toward more settled societies. However, the mystery deepens when archaeologists examine the layers of carvings more closely. The markings do not appear to have been created at the same time. Some symbols are deeply weathered and ancient, while others look comparatively newer. In several places, later carvings appear to overlap older ones, suggesting that the cave may have been revisited repeatedly by different groups of people over many centuries, or perhaps even millennia. This layered history transforms the cave walls into a kind of prehistoric archive. Each generation may have added its own symbols to the stone, leaving behind a visual conversation that stretches across vast spans of time. If this interpretation is correct, the Edakal cave was not merely a shelter or dwelling place. Instead, it may have functioned as a sacred or culturally significant site, where different communities returned again and again to record events, beliefs, or identities. The age of the carvings alone would make Edakal remarkable, but what truly sets the site apart is the strange and intriguing nature of the symbols themselves. Unlike many prehistoric cave sites where artists focused primarily on animals or hunting scenes, the carvings here include a mixture of abstract symbols, human figures, geometric patterns, and mysterious signs that resemble early forms of writing. Some of these shapes appear repeatedly, forming patterns that seem too deliberate to be random decoration. Researchers have noticed combinations of lines, crosses, ladder-like forms, and complex shapes that look strikingly similar to symbolic systems found in other ancient cultures. A few scholars have even pointed out similarities between certain Edakal symbols and signs associated with the ancient Indus Valley civilization, which flourished thousands of years later in a completely different region of the Indian subcontinent. The possibility of such a connection is fascinating, but also controversial. If the resemblance is more than coincidence, it could hint at cultural exchanges or symbolic traditions that travelled across long distances in prehistoric times. Yet there is still no definitive evidence that the carvings represent a true writing system. Without a decipherable structure or known linguistic reference, the symbols remain silent, their meaning locked within the stone. This uncertainty raises one of the most compelling questions surrounding the Edakal cave petroglyphs. Were these carvings meant to communicate information, or were they purely symbolic expressions tied to rituals and belief systems? The repetition of certain shapes suggests that they carried specific meanings for the people who created them. Some researchers believe the symbols could represent clan markers, territorial signs, or spiritual symbols associated with ancient myths. Others speculate that the carvings might have functioned as a kind of proto-writing system, an early stage in the long evolution of human communication before the development of formal scripts. If this theory holds any truth, the cave walls may preserve one of the earliest examples of symbolic language in South Asia. Yet without the ability to interpret the symbols, this possibility remains a tantalizing mystery. Each carved line and geometric shape becomes a fragment of an unknown message, left behind by people whose thoughts and intentions have long since disappeared into the past. Alongside these enigmatic symbols, the cave also contains a surprising number of human figures and complex scenes. These images are particularly unusual when compared with many prehistoric carvings found elsewhere. Rather than simply depicting animals or hunting activities, the Edakal figures appear to represent individuals engaged in meaningful actions or social events. Some figures seem to wear elaborate headgear, possibly indicating status or ritual roles. Others appear to hold tools or weapons, suggesting scenes connected to daily life or ceremonial practices. In certain areas of the cave wall, multiple figures stand close together, arranged in ways that resemble gatherings or group activities. These compositions hint at a level of narrative complexity rarely seen in ancient petroglyphs. Instead of isolated drawings, the carvings appear to capture moments, perhaps stories, rituals, or symbolic representations of important events within the community. A particularly intriguing aspect of these figures is the possibility that they represent leaders, shamans, or individuals of special significance within prehistoric societies. The presence of distinctive head shapes and exaggerated features may indicate that certain individuals were meant to stand out from the others. Some scholars have suggested that these carvings might depict mythological figures or ancestral spirits rather than ordinary people. If so, the cave could have served as a sacred space where ancient communities recorded their cosmology and spiritual beliefs directly onto the stone walls. This would transform the cave from a simple archaeological site into something closer to a prehistoric sanctuary, a place where art, religion, and identity merge together. The more researchers examine the carvings, the more complex the mystery becomes. Instead of presenting a single clear narrative, the cave seems to contain fragments of many different stories layered across time. One generation may have carved symbols representing its cultural identity, while another added figures associated with rituals or legends. Over centuries, these images accumulated, gradually covering the stone surfaces with a dense network of engravings that reflect changing beliefs and traditions. In this way, the cave functions almost like a cultural memory bank, preserving traces of human thought from long before written history. Today, visitors who enter the Edakal cave often experience a strange sense of connection to those ancient artists. The carvings are not polished sculptures or carefully painted murals. They are rough, direct marks carved by human hands into solid rock thousands of years ago. Each line required effort, patience, and intention. Whoever created them must have believed that the act of carving carried meaning, perhaps spiritual, social, or symbolic. Yet despite decades of study, the true purpose of these images remains uncertain. Were they messages meant to be understood by future generations, or were they sacred symbols intended only for those who already knew their meaning? The Edakal cave petroglyphs continue to challenge modern assumptions about prehistoric cultures in the Indian subcontinent. They suggest that long before formal civilizations emerged, early communities were already capable of complex symbolic expression and visual storytelling. Whether these carvings represent early writing, ritual art, or something entirely different, they reveal a level of intellectual and cultural sophistication that still surprises researchers today. And perhaps the greatest mystery of all is that the answers may still be hidden within the stone itself, waiting for someone to finally understand the language of these ancient marks carved into the heart of the mountain. The Bingling Thousand Buddha caves rise dramatically along steep cliffs beside the Yellow River in China's Gansu province, forming one of the most visually striking and historically complex Buddhist cave sanctuaries in Asia. Carved directly into sandstone cliffs overlooking the ancient river corridor, the site contains hundreds of grottos, statues, and carved niches that accumulated over centuries of artistic and religious devotion. Archaeologists believe that the earliest caves were created during the 4th century, with major expansions occurring through successive dynasties, including the Western Qin, Northern Wei, Sui, Tang, and Song periods. Over time, monks, artisans, and patrons transformed the towering cliff face into a monumental vertical gallery of Buddhist imagery. Yet beyond the religious symbolism and artistic beauty of the caves lies a deeper layer of intrigue. The techniques used to carve the niches, organize the cliffside complex, and especially preserve vibrant colors for more than 1,000 years continue to raise questions about the technological knowledge and craftsmanship of the ancient builders. From a distance, the cliff face appears almost like a natural rock wall, punctuated by hundreds of carefully shaped cavities. These niches vary widely in size and purpose. Some are small, shallow recesses holding modest statues, while others are large chambers containing monumental sculptures reaching several meters in height. Many of these niches are positioned at dizzying heights along near-vertical rock surfaces, a fact that immediately raises questions about how ancient workers could have safely accessed such locations. Unlike many other cave temples carved into slopes or hillsides, the Bingling cliffs are steep and irregular, making large-scale construction extremely challenging. Modern researchers speculate that complex wooden scaffolding systems must once have been erected along the cliff face, allowing artisans to carve, sculpt, and paint the figures. However, because wood decays quickly and leaves little trace after centuries, physical evidence of such structures has largely disappeared. This absence of direct archaeological remains leaves historians reconstructing the building process largely through indirect clues, tool marks, and engineering analysis. Equally fascinating is the precision with which many of the niches were carved. The interior surfaces of certain grottos display remarkably straight planes and well-defined corners, suggesting a highly controlled carving process. Although the artisans relied on relatively simple tools such as iron chisels, stone hammers, and metal picks, the resulting surfaces often appear surprisingly regular. In some areas, repeated tool marks indicate careful, systematic cutting rather than rough excavation. Achieving this level of precision on uneven cliff faces would have required careful planning and coordination. The builders needed to evaluate the structure of the rock, avoid natural fractures, and ensure that the carved chambers would remain stable over time. In addition, the placement of niches across the cliff face appears far from random. More archaeological surveys have shown that many of the caves align in visual sequences or layered vertical groupings, suggesting that the layout may have been planned with both symbolic and practical considerations in mind. Yet perhaps the most intriguing technological aspect of the Bingling caves lies not in the carving itself, but in the extraordinary survival of their painted surfaces. Many statues and grotto walls were originally covered with vivid pigments, transforming the cliffside sanctuary into a vibrant spectacle of colour. Even today, traces of red, blue, green, and gold can still be seen on certain sculptures, despite the passage of more than a millennium. The survival of these pigments is remarkable given the harsh environmental conditions of the region. The caves have been exposed to fluctuations in temperature, wind erosion, humidity changes, and occasional flooding from the nearby river reservoir. Under such conditions, painted surfaces would normally deteriorate rapidly. Yet in Bingling, many pigments remain visible, raising questions about the materials and techniques used by the original artists. Scientific analysis has revealed that the pigments were derived primarily from natural mineral sources. Red colours often came from iron oxides, while blues could be produced using azurite or other copper-based minerals. Green pigments sometimes originated from malachite, and white highlights were created using clay or calcite-based compounds. However, pigments alone cannot explain the remarkable longevity of the paintings. Equally important were the binding agents used to attach the colour to the stone or plaster surfaces. Researchers have detected traces of organic compounds that may have functioned as natural adhesives. These could have included plant gums, animal glue, or other biological materials capable of bonding mineral particles to the carved surfaces. The process of applying paint to the sculptures was also technically sophisticated. Before pigments were added, artisans often prepared the surface with a thin layer of plaster made from clay, sand, and sometimes organic fibers. This base layer smoothed the rock surface and created a stable foundation for painting. Once dry, pigments were carefully layered on top, sometimes in multiple coats to achieve richer color tones. In some cases, fine line work and delicate shading techniques were used to enhance facial expressions and clothing folds on the statues. Such artistic precision required not only aesthetic skill, but also a deep understanding of how materials would interact with the environment over time. What remains puzzling to scientists is how consistently effective these techniques were across different periods of construction. Some caves built centuries apart still show pigments that survived with surprising clarity, suggesting that knowledge about pigment preparation and application was transmitted across generations of artisans. Yet written records describing these painting methods are extremely rare. Much of what researchers know today comes from chemical analysis of microscopic pigment samples rather than historical texts. This leaves many questions unanswered. Did artisans follow standardized formulas for pigment mixtures and adhesives? Were certain workshops responsible for maintaining specialized knowledge about painting techniques? Or did regional traditions gradually refine these methods through trial and experience? The placement of paintings within the caves may also have contributed to their preservation. Many of the most colorful sculptures are located deep within niches or grotto chambers where direct sunlight rarely reaches the surface. Reduced exposure to ultraviolet radiation would have slowed pigment degradation over time. In addition, the surrounding rock may have created relatively stable microclimates that protected the painted surfaces from extreme environmental changes. Even so, the survival of pigments for more than 1,000 years remains an impressive achievement, considering the technological limitations of the time. Today, the Bingling Thousand Buddha Caves continue to attract archaeologists, conservation scientists, and historians seeking to understand the full story behind their construction. Modern technologies such as 3D laser scanning, digital imaging, and chemical spectroscopy are helping researchers document the caves in unprecedented detail. These tools reveal subtle tool marks, pigment residues, and structural features that were previously difficult to study. Yet even with these advanced methods, the site retains an air of mystery. The artisans who carved and painted the Bingling Caves left behind no detailed manuals explaining their techniques. Instead, their knowledge survives only in the physical traces embedded within the rock itself. Standing before the towering cliff face today, it is hard not to wonder about the generations of craftsmen who transformed a remote sandstone wall into a monumental sanctuary of art and faith. Their work demanded engineering skill, artistic vision, and extraordinary patience. The colors that still remain on many statues reveal a surprisingly advanced understanding of materials and preservation long before modern chemistry. In this way, the Bingling Thousand Buddha cave niches stand not only as a spiritual monument, but also as a powerful testament to the ingenuity of ancient artisans whose techniques continue to intrigue researchers more than 1,000 years later. How do you think ancient artisans were able to create paint layers that could survive for more than 1,000 years under such harsh natural conditions? Share your thoughts or theories in the comments below. The Bzeklic cave complex, often known as the Bzeklic Thousand Buddha Caves, lies carved into the cliffs of the Flaming Mountains near the Turpan Basin in what is now Xinjiang, China. For centuries, this region stood along one of the most important arteries of the Silk Road, where merchants, monks, travelers, and entire cultures moved between east and west. Hidden within the reddish desert cliffs are dozens of ancient Buddhist caves that once formed a thriving monastic center. Although many Silk Road sites have been studied extensively, the Bzeklic caves remain one of the most fascinating and mysterious examples of how religion, art, and technology intersected in the ancient world. What makes this place extraordinary is not simply its age or location, but the remarkable artistic achievements preserved within the caves, especially the astonishing Buddhist murals that still survive in the middle of a harsh desert environment. The most striking and mysterious feature of the Bzeklic caves is the vast collection of Buddhist murals that once covered nearly every surface of the cave interiors. Walls, ceilings, and vaults were decorated with elaborate scenes depicting Buddhas, bodhisattvas, celestial beings, and episodes from Buddhist scriptures. These paintings were not simple religious decorations. They were executed with extraordinary skill and detail, reflecting a highly developed artistic tradition that flourished along the Silk Road between the 6th and 14th centuries. The murals portray intricate robes, delicate facial expressions, and complex narrative scenes filled with symbolic imagery. Even more remarkable is the fact that many of these colors have survived for over 1,000 years in an extremely dry desert climate. Brilliant reds, deep blues, and golden tones still appear vivid today, giving modern visitors a glimpse of the dazzling visual environment that ancient worshippers would have experienced when entering these sacred spaces. The preservation of these pigments remains one of the most intriguing aspects of the site. Researchers have discovered that many of the colours were created using finely ground mineral pigments, including compounds derived from copper, iron oxides, and other natural minerals. These materials were mixed with organic binders and carefully applied to prepared plaster surfaces on the cave walls. Yet despite extensive scientific analysis, historians and conservation scientists still debate the precise techniques used by the ancient artists. Some pigments appear unusually stable, maintaining their vibrancy far longer than many comparable murals elsewhere in Asia. This has led scholars to suspect that the artists possess specialized knowledge of pigment preparation and protective layering techniques that are not fully understood today. The fact that such sophisticated painting methods were employed in a remote desert monastery suggests that the Bzeklic complex was not an isolated outpost, but part of a much larger artistic and religious network stretching across Eurasia. Beyond their technical brilliance, the murals also reveal an extraordinary cultural fusion that reflects the diversity of the Silk Road. Within the paintings, scholars have identified stylistic influences from Indian Buddhist art, particularly the traditions associated with Gandhara. At the same time, elements of Persian and Sogdian artistic styles appear in the clothing, facial features, and decorative motifs depicted in the murals. Chinese Tang Dynasty artistic conventions are also present, especially in the arrangement of figures and the fluid elegance of certain compositions. Perhaps most fascinating are the depictions of Uyghur nobles and donors shown in prayer before the Buddha. These figures often wear distinctive Central Asian garments, and sometimes display physical features that suggest a mix of ethnic backgrounds, including lighter hair and different facial structures than those seen in classical Chinese Buddhist imagery. The presence of these donor portraits provides valuable historical evidence that the Uyghur rulers of the region actively supported Buddhist institutions before the gradual spread of Islam across Central Asia. The caves themselves are equally impressive from an architectural perspective. Originally, the complex may have contained around 70 or more carved chambers, each designed for different religious purposes. Some were small meditation cells used by monks, while others were larger ceremonial halls where rituals and teachings took place. Several caves feature a central pillar structure that allowed devotees to walk around it in a ritual practice known as circumambulation, an important aspect of Buddhist worship. Carving these spaces into the fragile sandstone cliffs required careful planning and skilled labor. The builders needed to ensure that ceilings would not collapse and that walls would provide stable surfaces for plaster and painting. Despite the challenges of the desert environment, many of these chambers have survived for more than a millennium, demonstrating a surprising level of engineering knowledge and craftsmanship. Yet the history of the Bzeklic caves is also marked by destruction and loss. Many of the murals visible today are incomplete because the faces of figures were deliberately damaged or scraped away at some point in history. Scholars believe this may have occurred during periods of religious transition, when Buddhism declined in the region and Islamic communities became dominant. In some cases, the damage may also have been caused by later visitors who did not share the same reverence for Buddhist imagery. Adding to the tragedy, numerous murals were removed entirely during expeditions in the late 19th and early 20th centuries, when foreign explorers and archaeologists cut painted sections from the cave walls and transported them to museums in Europe and elsewhere. As a result, pieces of the Bzeklic murals are now scattered across collections in several countries, leaving the original caves only partially intact. Another mystery surrounding the site concerns the eventual disappearance of the monastic community that once inhabited these caves. Historical evidence suggests that the Bzeklic complex thrived during the height of Uyghur Buddhist culture between the 9th and 12th centuries. Monks studied scriptures, pilgrims visited the caves, and wealthy patrons commissioned new murals and sculptures. However, As religious and political dynamics shifted across Central Asia, Buddhism gradually declined in the region. The precise details of how the monastery was abandoned remain unclear. Unlike some historical sites that show evidence of violent destruction, Bzeklic appears to have been slowly deserted over time. The caves remained hidden in the desert landscape until modern explorers rediscovered them, revealing a silent archive of artistic and religious history preserved within the cliffs. Today, the Bzeklic caves stand as one of the most remarkable surviving monuments of Silk Road civilization. They offer a rare window into a world where merchants, monks, and artists from many cultures interacted and shared ideas across vast distances. The murals, in particular, continue to captivate scholars because they embody both artistic beauty and technological sophistication. The enduring colours, the delicate brushwork, and the fusion of cultural influences all point to a sophisticated artistic tradition that flourished in one of the most unlikely environments imaginable. In the middle of a remote desert valley, far from the great imperial capitals of Asia, ancient artists created masterpieces that still challenge modern understanding of early painting technology. Ultimately, the Bzeklic caves are more than a group of ancient religious chambers. They represent a meeting point of civilizations along the Silk Road. The mysteries of their pigments, artistic influences, and the disappearance of the monastery continue to spark debate among historians and archaeologists, reminding us that the ancient world was far more interconnected and advanced than we often imagine. How do you think the murals inside Bzeklic Cave were able to preserve their vivid colours for more than 1,000 years in such a harsh desert environment? Share your thoughts in the comments below. The Huashan Cliff Caves, located in Anhui Province near the modern city of Huashan in eastern China, represent one of the most enigmatic artificial cave complexes ever discovered. Hidden within steep cliffs along the Sinan River, these enormous chambers remained largely unknown to the modern world until 1999, when local exploration revealed that the openings scattered across the mountainside were not natural cavities, but entrances to a vast underground construction carved directly into solid rock. When researchers first entered the caves, they expected to find small grottos or shallow tunnels. Instead, they encountered immense halls, corridors, staircases, terraces, and pillars carved from the mountain itself. What appeared from the outside as a simple cliff face concealed a network of spaces so large that some chambers span thousands of square meters and rise more than 30 meters high. Today, archaeologists have identified more than 36 caves in the Huashan complex. Yet many experts believe that additional chambers may still lie hidden within the surrounding rock formations. From the moment of their rediscovery, the caves immediately captured the attention of historians and archaeologists, not only because of their enormous scale, but also because their origin and purpose remain deeply mysterious. The physical structure of the caves suggests an extraordinary level of planning and engineering. Inside many chambers stand massive stone pillars that appear to support the ceilings, yet these pillars were not constructed separately. They were intentionally left behind as the surrounding rock was removed during excavation. This technique implies that the builders understood how to maintain structural stability while carving out enormous interior spaces. Some halls contain carefully shaped platforms, staircases connecting different levels, and corridors leading deeper into the mountain, creating the impression of a deliberately designed architectural complex rather than a randomly excavated series of tunnels. In certain chambers, the layout appears surprisingly symmetrical, with pillars arranged in orderly rows and ceilings shaped to maintain balance across wide spans of stone. Archaeologists estimate that constructing the entire cave system would have required removing hundreds of thousands of cubic meters of rock, an immense amount of material considering the technological limitations of ancient societies. Such an undertaking would have required a large workforce, organised labour, and a clear understanding of how to excavate stone without collapsing the surrounding structure. Another striking feature of the Huashan cliff caves is the distinctive pattern of tool marks that cover the interior surfaces. The walls, ceilings, and pillars throughout the caves display thousands of parallel grooves carved into the stone, forming a repeating texture that stretches across the rock like carefully drawn lines. These marks appear remarkably consistent, suggesting that the excavation process followed a systematic method rather than a chaotic breaking of stone. Some researchers believe these grooves were left intentionally, almost perhaps as part of a specific carving technique used to remove rock efficiently while maintaining stability. Others have proposed that the patterned surfaces may have served an aesthetic purpose, giving the interior chambers a uniform appearance. Yet despite these visible traces of human labour, archaeologists have discovered very few ancient tools within the caves themselves. The absence of clear construction equipment makes it difficult to determine exactly how the excavation was carried out. Historical documents from the region also provide little direct information about a project of this scale. Some scholars have suggested that the caves might date to the Eastern Han dynasty, but without definitive written records or datable artifacts, the exact period of construction remains uncertain. Equally puzzling is the question of what happened to the enormous quantity of rock that must have been removed during excavation. If the chambers were carved entirely from solid stone, the builders would have had to extract hundreds of thousands of tons of material. Normally, such a massive operation would leave behind large piles of debris or clear evidence of transportation routes used to remove the rock from the site. Yet around the Huashan cliff caves, archaeologists have found surprisingly little indication of where this excavated stone went. There are no obvious spoil heaps nearby, nor are there nearby ancient structures that can be definitively linked to the material removed from the caves. This absence of physical evidence creates a logistical mystery. How did ancient workers transport such a vast quantity of stone without leaving recognizable traces? Some researchers speculate that the stone may have been carried away for construction projects in distant settlements, while others suggest that centuries of erosion and natural processes may have erased the evidence. Nevertheless, the missing rock remains one of the unresolved puzzles surrounding the site. Despite the many architectural and engineering mysteries associated with the Huashan cliff caves, the most fascinating question of all concerns their original purpose. Why were these enormous underground chambers carved into the mountain in the first place? After decades of study, archaeologists still have no definitive answer. Several theories have been proposed, yet none fully explains the evidence found inside the caves. One possibility is that the caves were originally used as quarries, where stone was extracted for building projects elsewhere in the region. At first glance, this explanation seems logical, since the excavation clearly involved removing huge amounts of rock. However, the carefully shaped pillars, staircases, and symmetrical halls inside the caves suggest that the builders were not simply extracting stone, but intentionally shaping the interior spaces. Quarry operations typically focus on efficiency rather than architectural design, making it difficult to explain why the caves contain such elaborate layouts if their only purpose was mining. Another theory suggests that the caves may have served as hidden storage facilities or military depots during periods of conflict. The large interior halls could theoretically have accommodated enormous quantities of grain, weapons, or other supplies. Their location within steep cliffs might also have provided natural protection and concealment. However, archaeological investigations have found little evidence of prolonged human occupation within the caves. There are few traces of everyday artifacts, storage containers, or infrastructure that would normally accompany large-scale logistical operations. Without such evidence, the military storage theory remains speculative. A third hypothesis proposes that the caves may have had a ceremonial or religious function. Throughout history, caves have often been associated with sacred spaces, spiritual rituals, or symbolic journeys into the depth of the earth. The grand halls within the Huashan complex could have provided dramatic settings for gatherings or ceremonies. Yet unlike well-known religious cave complexes elsewhere in China, the Huashan Cliff Caves contain almost no statues, inscriptions, murals, or other religious imagery that would clearly indicate a sacred purpose. The absence of such symbols weakens the argument that the caves were primarily spiritual sites, because none of these explanations fully accounts for all the evidence. The true purpose of the Huashan Cliff Caves remains one of the most enduring mysteries in Chinese archaeology. The caves stand as monumental examples of ancient engineering, demonstrating that their builders possessed remarkable skill and organization. Yet the reason they devoted so much effort to carving vast chambers into the mountainside has been lost to time. Today the caves remain silent witnesses to an unknown chapter of human history, their immense halls echoing with unanswered questions, even in a civilization with one of the world's richest and most detailed historical traditions. The Huashan Cliff Caves remind us that some achievements of the ancient world can still remain unexplained, leaving modern researchers to wonder not only how they were built, but why they were created at all. In your opinion, what was the true purpose of the Huashan Cliff Caves? Could they have been a massive ancient quarry, a hidden storage complex, or perhaps a ceremonial structure whose history has been lost over time? Share your thoughts and theories in the comments below,